Yes, I'm here. People are joining still. They have created a new session. Some problem is there in that session, it seems. But few people are still joining. Can let us wait for them. Right. Okay. See, people are thinking that so neutral wire directly can be connected. No, no, yeah. This is the circuit diagram, but we are having which one here? Correspondingly, one box will be there. Internally, circuit is star. Outside, what are the available terminals here? R, Y, B only, the available terminals. Now tell me, where is a neutral point to connect the wattmeter? This is the current coil connected. Okay. Where you connect neutral point here? That's why neutral point will be there, but that is in the load box. Outside terminals are only, what is that? 3. So therefore, star, 3-phase, 3-wire will say. Suppose if I want to take star, 3-phase, 4-wire, suppose what is it? Star, 3-phase, 4-wire means some load will be there internally, star connected load. Outside they will bring 4 R, Y, B, N. Now you can use it. Sir, 1 watt meter here too. Here like this we can connect. So that's why it is not the matter of concentrate. It is not the matter of neutral point is there. Why can't we connect directly? No, yeah. This is circuit diagram. That's why it is looking like that. But this is there in the internal circuit of the corresponding load box. That's why whatever I told you, yes, this one. Now, what is the universal method? 2 watt meter method is 2 watt meter method is universal method. Clear? Right. Now, in this 2 watt meter method, what is there? Right here, power, active power we have calculated, reactive power we have calculated, apparent power you have calculated, as well as power factor angle and power factor. All these are being calculated. 1 second. Right. A few people called me regarding, sir, we are unable to join, etc. No problem. I'll be revising only. No, by the time the people will be joining. Few people are facing the problem. Kindly let us wait. Right. This I'm revising. By the time those people will join. Those who join, kindly don't message like I face the problem and all. At least finally you join. No, it's good. Right. Okay. Very good. Sir, all these can be determined with the 2-watt meter method. That too, without depending on neutral wire in the star connection, without opening the delta connection, the delta loaded notation. So therefore, ultimate method is 2-watt meter method. And we have seen so many questions also. And in this, what is the power factor formula? Cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Right? This is the total thing. I did not start anything. No need to worry. No need to worry. I did not start anything. Just I'm brushing up. That's it. Just brushing up. Yesterday's topic only. Just I'm revising. No need to worry. And what is that? Less than 0.5 power factor is there. One watt meter will be positive. Other watt meter will be negative. But how do you get the negative reading? I told you by reversing one of the coils connection, whatever the value you are getting, then simply reverse. That is WT is negative. Right? So this is the total discussion we have taken. And still people are getting confused. See here, RYB sequence. RYB sequence means here this is R, this is Y, this is B. Okay, this is sequence. But I told you yesterday, again you are asking the same thing. Kindly watch the recorded video. Every statement will be given. Right here. Sir, I'm connecting current coil here. Okay, where are connecting current coil? IR to N. So simply what we say, IR we say. Sir, potential coil is between R and B, right? See, wattmeter reading should be written as potential coil voltage, current coil current, and cos of this one. What I told you, where we have connected the potential wattmeter R phase to B. So therefore, RB we have to write. But people are saying that so sequence means RYB, RYB, RYB. No, sir. Yes, RYYB. Should be that is sequence for terminology purpose. But where we have connected the wattmeter according to the wattmeter connection, we need to go for it. According to the wattmeter connection, we need to go for this. Okay, and current is anyway IR only. Angle between VRB and IR. Right? Once you followed all the questions, then you all doubts will be clarified. One question, immediate doubt, typing the message to me, no use, no use. That's why, okay, why he has taken like this? Means you missed the class actually. Okay, again you are watching the video and all. Again, next question. Again, finally you will get the complete thing. And people message me also, sir, I have revised the total thing. Now I got all the clarities with respect to questions and terminology also. Like that also people message me. Means that is what the way. One question you did. Immediately taking the photo, sir, clarify. Second question, sir, the revised video is there, but you did not follow anything. Few people, not everyone. Yes, very good. Karthik, very good. Yes, yes. Right. Here, current will be, here problem, current is not IRB, current is IRN because neutral wire is there here. Neutral wire is there, means IRN or unit rate, just IR. Just IR because this is the load not connected between R and B directly. R to N is there, N to B is there, fourth wire is not there, fourth point is there here. But doubt is there here, sir. In one more question, you have taken like this, no, sir. This is R. This is now. You only tell me where this current IR is it neutral? No, he has given that this as the neutral N, this as the B. So that's why in this case the potential coil is V. Where we have connected the potential coil? B and N. I have taken BN. Where he has given the current coil connection R to Y. That's why I have taken IRY. But in this, three loads are shown. Three loads are shown automatically R to N. So IR to N or simply IR we have to write. Right? Okay. Right. Jada Pradeep, I'll give the contact number. Just kindly contact him. At the end of this, I'll give you. Right. If any technical problem is there, don't worry. I'll give the number, corresponding person number. You can contact him. No problem. Right. Okay. This is the total list. That's why whatever the actually we have taken last question. No, in that I have revised the entire topic. Also 3 wattmeter method. Yes or no? 1 wattmeter read 0, other wattmeter read 0 automatically. Yes, we can go for the in that also lagging is there, and then VRY is there, VRB is there, like the different combinations are. But be clear, sequence means terminology point of view. Check it. R is there first, Y is there later, B is further later. So therefore, what is sequence? Hold the junction, rotate in anti-clock, R, Y, B. So therefore, R, Y, B is a sequence. Right? So this is a total discussion regarding yesterday's class revision, just circuit diagram and approach. Now, a new method to complete this entire chapter. A new method is there. What is it? Here. I'm giving the heading as a question for practice purpose. Right. And one more thing. Tomorrow class is there. Tomorrow class is there. Actually, Saturday break will be there. No, but tomorrow I'm taking the class. Tuesday or Wednesday, due to some other work, I'll be taking the break on that day. I hope everyone can support. Tomorrow class is there, same time 5 to 9 I'll be taking, right? But this break will be given on Tuesday or Wednesday. I'll let you know. Okay, right. Thank you. Right? I'll let you know after this again. I'll tell you regarding this at the end of the session also. Right, sir. Dash power measurement. Dash power measurement by 1 watt meter means how many he has connected? Only 1 watt meter. But connection we don't know right now. Let us see about the connection. Let us see about the connection. Let us see about the connection. Right now, what is that connection? No, concentrate. Sir, this is R, Y, B. Explanation purpose, I told you already, Z will be taken. Assume that it is a lagging load, for example. Okay. Now, how the wattmeter is connected? Concentrate. Sir, current coil is connected in R phase. Yes. Potential coil is being connected between other two phases. First of all, the moment I'm saying this, so how is it possible? All I told you, M, L, C, V left free at whatever the connection, at whatever the plus we want to connect, we can connect it. No need to worry. No need to worry at all. Clear? Right? Now, what is it? What meter reading? He's asking. Very simple here. Yesterday's topic only, but different connection. Different connection. What is it? First point. Sir, W equal to, first, the moment you see the circuit diagram, write the wattmeter connection first. Voltage, nothing but potential coil, current, cos of angle between these two. Cos of angle between these two. Okay. Sir, what is the voltage of potential coil? Check it here. This is connected. This is connected across B and Y. You can take VBY. You can take VYB also. Why? Because this is connected in R phase between these two. So therefore, no preference. Suppose R to B is there, RB we have to take. But here, placed in the R connection, but connected with respect to B and Y. No one should ask this question again. YB or BY, anything you can take. But assumption is nothing is given means RYB sequence. Therefore, Y and B or B and Y, anything you can take. I'm repeatedly saying this will be general doubt. I'm revising that. Still people are asking, means you are not listening the class. That's it. Simply concentrate. VYB. Okay. Sir, what is the current? IR. I'm repeating. You can take YB or you can take BY. No problem at all. No problem at all. Only plus to minus, minus to plus will be changing. That's it. Will be same. Magnitude will be same. Sir, VYB and IR. VYB and IR. Okay, sir. Let me draw the phasor diagram because angle we require. VYB, VL, IR, IL we can write it, but angle we require. So how to get that angle? Right, Karthik and Shamala correct, but let me explain here. Sir, this is VRN, okay, and this is VYN. This is VBN. Okay, right, sir. IR we require. Which one? Lagging. So therefore, IR lags the VRN by 5 because load 1, load 2, load 3 means load means one phase means phase current lags the phase voltage only. Phase current lags the phase voltage only. Okay, sir. VYB, I told you in yesterday's class, VYB means automatically VYN minus VBN. Okay, VYN is there, VBN is not there. Sir, minus VBN is not there. Simply take this as which one? Minus VBN. Minus VBN. Okay, now finally, what is it here? VYN minus VBN. So final answer will be VYB. Now, which angle we require? Which angle we require? Concentrate. Angle between VYB and IR. Sir, VYB and IR. This angle we require. VYB and IR. What is this angle? If you get it, thing will be done. What is it? Let us take. Again, I'm verifying. Again, I'm giving the same explanation. Kindly concentrate here. Kindly concentrate. Sir, what is this angle? 120. What is this angle? 180 because straight line. Therefore, what is this angle? 60. What will be this angle? 30. Because parallelogram law half 30 plus 60. Therefore, you need to understand here this point to this point 90 degrees. So what we require? Here to here 90, but here to here only it is there. What is it here? 90 minus 5. So therefore, what is this? This is 90 minus 5. Okay, no substituted. Therefore, W is equal to VL. IR phase current or line current, star connection same only, no? Yes, cos 90 minus 5. Therefore, VL IL sin 5. So VL IL sin 5 means which one? reactive power. So simply, what is the heading here? Which power measurement here? Reactive power measurement. So therefore, if 1 watt meter is taken, current coil is connected in. Yeah, this is the first topic. This is the first topic in the today's class, right? What is it here? 1 watt meter, current coil is connected in R phase. Potential coil is connected between other two phases like Y and B. Yes, this is what the thing. What is it? Nothing you missed here. Yesterday's topic only, but an extra question. I am taking as a topic. That's it. It is a question model, but it is taken as the topic. That's it. So that's why current coil in one phase, potential coil in other two phases, then the wattmeter reads VL IL sin phi. VL IL sin phi. That is reactive power. That's it. Right? Many people message me like, sir, explain this. I'm not getting a topic is not done. Yeah. Topic, that's why I told you before sending me. See, only few people I'm responding means I can understand did they work or not. People are simply seeing the question, sending. I'm not at all replying them because you need to work. Simply seeing the question, taking the photo. Simply seeing the question, taking the photo. 500 people are there. How can I answer 500 into 2 questions in one day? At least 1,000 questions. Is it possible? Yeah. Never. That's why before answering, get it. Before answering, practice it, practice it, practice it. Then you need to ask. Simply, sir, I'm not understand the question. Just simply give the answer. Don't do that. Don't do that. Right? Right. Clear, guys? Right. Again, see, this is the English statement problem. Few people are asking that, sir, 1 watt meter means neutral wire should be there. No, neutral wire is there. We go for 1 watt meter. Don't come in the reverse way. If neutral wire is there, we go for the corresponding 1 watt meter method. Here people are asking, sir, neutral wire is there or not there? No problem. Why? You are not connecting with respect to neutral wire. Therefore, neutral wire is there or not there. It doesn't matter at all. That's why whatever we require, whatever is there, that only you take it. For everything that is not there, this is not there. What is my question? Current coil is in one phase. Potential coil is between other two phases. It is not the normal connection. It is the specific connection. You are not understanding this. So why neutral wire is not there? If you do that, you don't get the subject. Very simple point. That's why understand the statement. See, I'm keep on saying that those who are typing along with my explanation, definitely they don't get the subject. Right? I don't want to repeat, but still for your sake of convenience, I'm repeating. But if repeat like this, slowly, I'll change my habit. Okay, I'll note down those names. I don't answer those questions at all. Those persons, any doubt at all. Because you should not type along with my explanation. This is the 10th day. Still you are not changing. You're not changing. Clear, guys? So this is the total discussion regarding 90 minus 5, nothing but VLIL sin phi. Okay. Based on this, one question is there. Based on this, one question is there. So let me take that question. Let me take the simple question first. Simple question I'm taking. If you understand this, you can get the logic. I'll go back to the normal question now. Right. Concentrate here. In this connection, what is the wattmeter reading? This is the wattmeter. What is the wattmeter reading always? Simple logic here. Circuit is somewhat confusing, but answer is very simple. Sir, wattmeter. First you write this wattmeter. Voltage, current, cos of angle of those two. Okay, leave it. Sir, Potential coil measures voltage across. Potential coil measures voltage across Z2. So therefore, VZ2. Okay. Current coil measures the current through Z1 and Z2. Both are same. Is it no? So current coil measures the current through which one here? Z1 and Z2 both. People are getting confused. So current is coming here at this point divided. No, come on here. Potential coil. All I told you, very high impedance. Very high impedance means automatically current will be neglected. All I told you. Is or no? So therefore, what is it here? Current coil carries the current through Z1 and Z2 combination. So VZ2 and IZ2. Sir, power consumed by Z2 or power consumed by Z1 here? Check it. Zero, always wrong. Total power by both? No. Power consumed by Z1? No. Power consumed by Z2? Correct. In this way, simple questions are also possible. Yes, but many people give the correct answer. Very good. Very nice. Clear? Right. Now, in the same way, one more question. Right. What it reads, what this reads. I'm giving the options also. These are the options. Right. Simple logic here. To confuse you, diagram is given differently. But check it here. Sir, current coil is in one phase. Okay. Potential coil is between other two phases like this. So therefore, what is the topic here? Present topic only. Current coil is in one phase. Potential coil is between other two phases automatically. Automatically, what is that logic? Yes, sine phi only. So what is the answer here? EI sine phi. That is VLIL sine phi, but he has given us voltage, etc. So simply VLIL sine phi, EI sine phi. Cos phi, no. Cos phi will be active. It is not active. Tan phi, not at all there. So simply EI sine phi. And few people are asking that, sir, if I take VBY, it will be 90 plus 5. What is your problem? Then all I told you. That's why I'm saying that listen my statements clearly. You can take VYB here. You can take VBY here. Only sign will be different. Nothing but one will be absorbed, one will be delivered, will be there. So that's why reactive power nature is there or not. I told you. Still people are asking. Finally concentrate. See, if you take VBY, it may be 90 plus 5. It may be 90 plus 5, but even though no problem, cos 90 plus 5. What is the magnitude will be? Sin phi only. Nature will be reactive power only. Reactive power only. Right? Anything. Is it balanced or unbalanced? If the connection is like this, automatically reactive power only. But explanation purpose, we take balanced load. That's what the point. Because this is 5, this is 90 something, we should say no. That's what balanced. But nature is valid for unbalanced loads also. Clear? Right. Now, let us take one more question. People are waiting for this. People are waiting for this. I will solve every question here. You no need to worry. People message me, sir, solve this question, solve this question. Now also people are asking, sir, in the material, 8th question, etc., etc. Concentrate. A wattmeter reads, kindly see this, a wattmeter reads 400 watts when its current coil is connected in the R phase and its pressure coil is connected between this phase and the neutral of a symmetrical three-phase system supplying a balanced star connected 0.8 power factor inductive load. Okay, up to this, kindly concentrate up to this. Let us draw the diagram according to the given question. According to the given question. Right? Concentrate. Here. Sir, a three-phase star connected load is there. Kindly, keenly observe this kindly. R, Y, B. R, Y, B. This is Z, Z, Z. Okay. What is the load? 0.8 lagging. 0.8 inductive load is given. Okay. Neutral wire is there or not there? No need to worry. Okay. Now, what he has given? Kindly observe this clearly. A wattmeter reads 400 watts when its current coil is connected in R phase. Okay. Current coil is connected in R phase. This is CC. And its pressure coil or potential coil is between this phase. This phase means like this. This phase and neutral of a symmetrical means neutral wire is given. Okay, right, sir. Neutral of this one. Sir, under this case, this wattmeter reads 400 watts. This is the total data up to this. This is the total data up to this in this entire statement. What is it? 1 wattmeter. Current coil is connected in R phase. Potential coil is connected between this phase and the neutral of a so and so system. Okay, sir. In this case, this wattmeter measures which value? In this case, this wattmeter measures which value? Single phase power or any combination of phases power or three phase means single phase. Check it here. Perfectly one phase only. Therefore, what we can write here? Here, this will be directly written as power single phase is equal to V phase, I phase into cos phi. V phase, I phase into cos phi. This is given as 400 watts. Okay, leave it. After that, I'll come back to this, but see, after that. Now, this statement, phase sequence is R, Y, B. That only I have taken R, Y, and B. Okay, right, R, Y, B taken. What will be the reading of this wattmeter? If its pressure coil alone, is reconnected between, its pressure coil alone is reconnected between the B and Y phases. So therefore, what is that? Current coil he has not disturbed. Current coil he has not disturbed. R, Y, B. Okay. And what is it? Z, Z, Z. Same. 0.8 lagging. Everything is same. Only what is it? Pressure coil alone is reconnected between B and Y phases. Is reconnected between B and Y phases. Okay. All other connections remaining as before. Means potential coil alone. He is connecting across B and Y phases. Now, this wattmeter reading is dash. That's what the question. Sir, we know that this wattmeter reading is which one? Yeah, VL, IL, sin phi. Just now I have taken the concept. What is it? In this model, VL, IL, sin phi. Okay, VL, sin phi. Sir, it is a star connection. VL can be written as root 3 V phase. I already told you in the yesterday's class. IL can be written as I phase into sin phi. Okay, sir. From this, V phase, I phase is equal to 400 by cos phi. Cos phi is 0.8. 400 by cos phi is 0.8. You will be getting 500. Okay. Now, sir, root 3 What is V phase I phase combination? 500. Sir, cos phi power factor is 0.8. So therefore, what is it? Here, cos phi is 0.8. I hope everyone knows that. It implies sin phi is equal to 0.6. Kindly don't ask me how. Find out phi, apply the sine. Okay, so therefore sin phi is 0.6. Therefore here 0.6. Now you will be getting 519.46 or 64, I think. What is it? Reactive power, volt ampere. Reactive unit is VAR, volt ampere reactive. Okay, 519.64. Many people messaging us, what is the answer? What is the answer? The topic is not yet completed here. That's why practice my questions first. After that, you think of other questions. Right, correct. Srividya, correct, right? Pratik Pramod, yes. Simple question, simple. But unless and until you understand the terminology, it is very difficult only. Once you understand the terminology, based on that, if you are able to draw the diagram, thing will be done. Very, 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 very simple. Clear? And one question I'm giving as the homework. Take this as a homework. I'm not giving the options. Yes, take this as a homework. Yeah, that's what. After my explanation, it will be simple. Yes, definitely. That's what I'm saying here. After the explanation from any person, it will be looking simple. But my question is, you need to practice again. Then after that, if you see the question, any question, it will also be looking very simple only. That's why I'm requesting. Yes, you need to practice. Yes, correct. It is not three phase, just reactive. I told you already in yesterday's class. What is that? Reactive power only. VLIL sin phi, just reactive. VLIL sin phi. This is just to Q, neither single phase nor three phase. That's phase. After that, if you want to get Q three phase, root 3 VLIL sin phi. This is three phase reactive. In yesterday's class, clearly gave you step 1, step 2, step 3 like that. This is just reactive. That's why I told you here reactive only, not any specific three phase or single. No, nature is reactive. That's it. Clear? So this is a total discussion regarding the entire power measurement, DC, single phase AC, three phase AC, and different possible questions we are taking. Right? Try this. This is the homework question, and this is the question we have to solve now. Different answers. 2000, 0, 3464. Why different? Come on. Twelve thousand, 3464, 2000, 3464. Many people are giving. Okay. Kindly take 2 more minutes and try. Take 2 more minutes and try. Come on. The question is very lengthy. This is the previous gate question only for instrumentation people. Previous gate question. Instrumentation, previous question. Still different answers. Okay, right. Concentrate. So why these many? I told you to come practice, right? I told you to come prepared. But many people give the correct answer. Sir, first of all, here VL is given. What is that? 400 volt. IL is given 10 ampere. Okay, right, sir. Which line it is? Three-phase line. Three-phase line. Okay, right, sir. What is that? Here, 1 wattmeter reading is which one? 2 wattmeter method. The first wattmeter connected to R and Y line reads 0. Sir, 1 wattmeter W1 W2 0. It implies power factor is how much here? 0.5. So 5 is equal to 60 degrees. Right? Many people are doing this mistake. Sir, W2 is equal to which value? VL IL cos 60. VL IL cos 60. What is that? VL 4000 into IL 10 cos 60.5. Many people gave this as a 2000 watts, but you are missing something. You are missing something. Concentrate here. What is a wattmeter reading? What is a wattmeter reading here? What is it? W2 VL IL, right? Cos 30 minus 5. Cos 30 minus 5. Why, sir? Means W1 means W1 is equal to VL IL cos 30 plus 5. Then only it will be showing 0. Why? Cos 90 0. Cos 90 0 means automatically 5 should be 60. That only we have got it. Therefore, other wattmeter reading is 30 minus 5. You're missing something. VL 400 into IL 10. Cos 30 minus 60. Cos 30 root 3 by 2. You'll be getting 2000 into root 3. You'll be getting 3464 watts. That should be clear with the each and every wattmeter reading. Bhaskar, you are given double. How? Why? Right. Yes, I told you the note. I told you note. Yes, very good, Sanjay. This question is based on the note. Very good. This is one method. Or other method also I'm giving. Very simple, sir. W total is equal to W1 plus W2 is equal to root 3 VL IL cos phi. You can do like this also. What is the total power? root 3 VLIL cos phi, total power. Sir, 1 wattmeter is 0 plus W2 is equal to root 3 into 400 into IL10 cos 60.5. You will be getting W2 reading is 3464 watts. You can do it either way. There, 1 wattmeter reading is 0. Other wattmeter reads 30 minus 5. But here people are asking, sir, how do we know 30 minus 5 only means? The wattmeter reading should be 0 when? What is that? 60. So 30 plus 60, 90. Cos 90, 0. Then, yes, it will be 0. Automatically, other will be 30 minus 5 only. You do like this. Otherwise, total power, very simple one. W total equal to W1 plus W2 equal to root 3 V, because this is total power. But W1 is 0. W2 will be, what is this? So that is what the question. You can do in that way or this way, no problem. Clear, guys? So this is a total discussion regarding measurement of power, right? Okay. Now let us do few more simple questions. Lengthy numericals and all we have taken. Now let us take one few simple questions. One second. Right. Simple conceptual question. Like this also the question will be given. In 2 wattmeter method of power measurement, one of the wattmeters will show negative reading when the load power factor angle is. He is not asking load power factor. He is asking load power factor angle is. Mridul Sharma, you try it after the class and check it. You try it after the class and check it. We can do many ways. We can do one of the methods I'm saying. Can't we do? That's why I told you. You try it. If any problem is there, then you talk to me. No problem. Right, very good. See, power factor must be less than 0.5. Power factor must be less than 0.5. Therefore, automatically, the power factor angle must be greater than 60. So, therefore, answer is direct. In this also, one more question is possible, right? Right. This is not a purely measurement question, but it is there in the measurement booklet. I kept intentionally. Try to answer this. This is basic circuit theory concept. The network theory concept. Okay, many people, different options. Few people give A, sorry. Few people have given A, B, C. I think no one has given D. Oh yeah, D also given. So you covered all options. Very good, very good. Very simple. Yeah. Always be clear. If the supply voltage or the supply current has the frequency F, then the power will be having the frequency of double the corresponding voltage frequency. So directly, what is it here? 100 hertz. How? I'll tell you. Actually, simply state for my measurement point of view, simple statement is sufficient. What is it? If the voltage has the frequency of 50 hertz, then frequency of power will be double that of the frequency. Yes, derived in the network theory. Those who have completed the network theory, they know this. But otherwise, no need to worry. I'm taking. Generally, I'll take like this in the network theory. V of t is equal to Vm sine omega t. I of t is equal to Im sine omega t. Means I'm taking a resistive load, for example. You can take inductive capacitor, anything. But I'm saying that simply resistive load I'm taking. Okay. Sir, what is power? Power P equal to V of t into I of t. What is that? Vm into Im sine and sine square omega t. After that, Vm Im sine square omega t means 1 minus cos 2 omega t by 2. After that, Vm Im by 2 minus Vm Im by 2 cos 2 omega t. This is the instantaneous equation. Instantaneous equation of the power. Okay, now, sir, concentrate. Sir, what is the voltage frequency? Omega. Current frequency, omega. But power frequency, what is that? Double. This is for which one? Resistive load we have taken, R load. But same thing is valid even for inductive and capacitive also. That's why proof I gave you. Answer is double. This is 50. So automatically 100 double will be there. Option D, no. Yes, cos 2 omega t. Very good, very good. Right. Average power is a magnitude. Concentrate here. Before asking the question, kindly think once. I'm saying think once. I'm not saying that don't ask. No, if you think, you can get the answer from your side only. People are asking, sir, what is the average power equation? Average power itself is a value. Where do you have frequency? Instantaneous power, instantaneous voltage, instantaneous current. Then we can say, what is it? Correspondingly, so and so power. But you may be asking, sir, average power V into I into cos phi. Even though you take any power, double the frequency, but writing point of view, we don't represent. So power equal to double instantaneous power equation I'm showing. Even though you take, what is it? Average power at which frequency means double the voltage frequency. It is operated. So no problem. Clear, guys? So this is one question. Actually, network theory model, but topic is related to that's why I'm giving. Right. After that, sir, in the concentrate, we have taken self-inductance of potential coil. We have taken. Yes or no? Error due to self-inductance of potential coil we have taken. Yes or no? What is that? What is it? Plus or minus tan phi, tan beta into 100 we have taken. Okay, sir. Already we have taken analysis also. Beta must be low, thereby error will be low during designing. Okay. Phi must be low, thereby error will be low during operation. Okay. But manufacturer side, beta is low. Okay. If beta is low, error is low. But not only this, some other method is also they are keeping. That is what I'm taking now. Elimination of error due to elimination of error due to self-inductance of potential coil. I'm taking one. Very, very simple idea. Very simple idea. Sir, I'm taking the circuit here. Current coil. Potential coil and resistance is there. In this some resistance is there and separate resistance. No, I'm keeping two resistances separately. Okay, this total thing is RP. This is potential. Already told you in the earlier class also. These are internally there. This is R extra connected. Combination is anyway RP. I told you. Right? I'm taking elaboratedly. Right, sir. This inductance is made up of very low, thereby beta is low, thereby error is low. Already we have concluded. Not only this, I want to reduce it further or eliminate it. I want to reduce it further or I want to eliminate. Reduce it further or eliminate. Right? What we have to do? Very simple. Yeah, just by connecting a capacitance across the total resistance, no, across the part of the total resistance. Across which part? Don't need to worry. Simply conceptual. Across the part of resistance. Okay, sir. What is the C value? What is the C value? Means concentrate. How you are eliminating means this capacitance will nullify this inductance. That's what the point. Capacitance leading, inductance lagging. That's why indirectly what we can say, capacitive effect nullify the inductive effect. That's what elimination of error due to self-inductance of potential coil. Okay, but if you observe this keenly, concentrate. Only potential coil I'm drawing here. Inductance, resistance, resistance, capacitance. We have taken this type of circuit somewhere else. We have taken this type of circuit somewhere else. Sir, LM. Here, LP. There, RM. Here, just R. Leave it. Here, RSE. Here, R and C. What is the C value we have taken here? This C value we have taken for, what is it? Frequency error elimination. Sir, indirectly, elimination of error due to self-inductance means inductance error. Frequency also comes into picture. No? That's why C value, this and this both are similar. So therefore, what we can say, 0.41 LM there, here LP. RSC there, here simply R. This is only for idea purpose have taken. Mubin, I think you have asked this only, but I wanted to conclude with this. Means self-inductance error is there, right? We minimized with respect to LP low. We minimized with respect to LP low. Other than that, manufacturer side only, they will be connecting the capacitance across the portion of the resistance so that this capacitance nullifying this means already it is low. Error is already low. That is also we are trying to minimize further. Ideally speaking, eliminated. So by using the capacitance, that's why C is equal to 0.41 LP by R square. Suppose in the examination, it may not be given, right? C proportional to the may be given, no problem. But this is the actual formula. Means same topic we have taken in the moving iron instrument. The terminology is different. That's it. Only terminology is different. Right now, Ravi Teja, kindly go through your question once. You can understand. Coil itself is inductance. Without the inductance, is it not possible? Means without the inductance, how can you frame a coil? How can you frame a magnetic field? Right? So therefore, answer is 0.41 LP by R square. Clear? Right. Based on this, one question I'm giving. Right. Here BD, right? Option B or option D? People are giving option B or option D. Try to understand. I will draw the diagram according to the circuit. A capacitor is connected across a portion of resistance of the multiplier, means resistance RSC, in order to make the pressure coil circuit of the wattmeter non-inductive, means inductive error is eliminated. Inductance is there, but behavior is non-inductive, so error is eliminated. The value of this resistance is R. The value of this resistance is R, while the, come on guys, while the total resistance of the inductance of the pressure circuit respectively Rp and L. Try to concentrate here. Sir, this is L. He has given L. Total resistance is Rp here to here. This is what the circuit. But here, where he has connected the value of this resistance, means which one? Across a resistance. So therefore, what is its value? Here he has connected the capacitance, that is C. What is value? This portion is R. To confuse you like this, it is given. That's why I have separated the two parts like this. Total is Rp. Where you are connecting, that is R. Okay, so therefore, what is the answer here? C is equal to 0.41 L by Rp square is there, but no here, this is R square. We don't connect the capacitance to the entire resistance. We connect the capacitance to only portion of the resistance, that is small r in this question. Okay, people are asking, sir, B or C? That only I told you. If this option is not given, then you can go for C. But if this option is given, perfectly correct. Perfectly correct. Therefore, B only. B only. Suppose if it is not given, this is also chosen if this is not given. But it is given, obviously this will, don't say both. If this is there, that will be the ultimate answer. Yugasri, not D here, not D. This is B only. D means total resistance. Kindly go back and see here. Rem and RSC. In our logic, combination is Rp. But we are not connecting across the total. In the formula, what is there here? 0.41 Lm by RSC square. RSC in series means across the capacitance. Yes, across the capacitance. Question is very simple, but what is it? Conceptual one. Right. Bhaskar, PSC is highly resistive. Why extra resistance? Kindly go back to the 2 days back class and watch the recorded video. I told many of the times. So this is the total discussion regarding measurement of power with different varieties of questions. I gave one question homework. Kindly come with the answer in the tomorrow's class. But one shot already gave the answer. Very good, very good. Other people after the class you can try. Right? Now, next one is measurement of energy. Measurement of energy. So, what is this? Right. One second. Sir, if resistance R is not given, instead of R, RPC, whatever they have given, where you are connecting the capacitance, that only to be answered. Where you connecting the capacitance, this portion. People are asking, sir, if this is not given, they cannot ask the question because where he has connected, we don't know. If we don't know where he has connected, we cannot answer. Even though, sir, RP, this R is not given, so can you take RP square? Never, never. I don't know. Why? Kindly go back to MI and concentrate. In the MI, I told you, this is RSC, REM. By REM square is not coming here, only RSC square. Suppose if it is not given, question is not framed. Question will not be framed. Because across which portion you are connecting the capacitance, if you are not having that, we cannot get it undoubtedly. That's what the point. Clear? People generally in my subject, there's a general question from many students. Sir, this is not given. Question is incomplete. That's why if I give you this means that is given, that is the question. Generally, people are thinking that, sir, if that is not given, what happens means question will not be framed. That's why that is what the question. Clear? Right. Now, very important, very much practical device. Whatever the device we see in our daily life, that is in our home, whatever the circuit we use, whatever the device we use, that is this only. So kindly concentrate more and more. Okay, right now. Sir, what is energy? First of all, which type of device we use? Energy meter. Energy meter. Okay, right. Sir, what is a unit? Joule or watt second. Okay, if the magnitude of the energy is increased, if the magnitude of the energy is increased, what is it? Watts. Suppose watt, seconds become minutes, minutes become hours. WH also we can use. That's why this meter is also called as, this meter is also called as, that is it, watt hour meter. Watt hour meter. Clear? Okay, after that, sir, this is which type of principle? Nothing but energy is equal to integral P into dt. What does it mean? Integrating power into time. All I told in the introduction day, integrating time means cumulative summation. So therefore, the device is called as integrating type instrument. Integrating type of instrument. Okay, after that, sir, here, this works on which principle? Induction principle. It works on induction principle. Right? In the deflecting torque notation, magnetic effect and electromagnetic effect, static effect, induction effect, and after that, Hall effect, thermal effect, like that we have taken now. Here, induction principle means two coils will be there. With the induction, the force will be produced. What is it? I'll tell you. And as this is induction principle, AC device only. Also, our topic is measurement of AC energy only, AC device. Okay, fine. This is the complete introduction regarding the energy meter. Okay, but very important note here is, sir, in your home, how many of you seen your current bill? I mean, power bill. Can you raise your hand? Don't say yes, typing the message. Only raise the hand. Only raise the hand. How many of you have seen the bill paper? Okay, everyone is saying yes. Okay, very good. In that bill, what did you see? Now you can type your answer. What did you see? Openly, obediently. Don't give diplomatic answer kindly. Very nice. Yeah, finally, many people accepted properly. Sir, final amount. Yeah, that is what tendency, right? How much money to pay? When should be paid? When should be the last date? When should be the last date? Mridil Sharma, have you seen all? Mridil Sharma, have you seen all? Very good, very good. Okay, right. Bill value. Major people will see the bill and a date. Okay, 16th of this June. Okay, right, over. But in that, unit one word will be there. Units means previous month 1995 units. This month 2100 in unit means 2100 minus 1995, 105 units you have consumed for the earlier month. In that way, you have to take. So therefore, what is the meaning of that unit? Be clear. 1 unit of energy. 1 unit of energy is equal to 1 kilowatt hour. 1 unit of energy is equal to 1 kilowatt hour. Means nowadays, what are I told you know? So therefore, one more unit kilowatt hour. So we can base the magnitude. So therefore, wherever we are using 1 kilowatt hour, that's simply taken as 1 unit. Suppose in your electricity bill, 250 units you consumed means 250 kilowatt hours of energy you utilized. That's what the actual point. 250 kilowatt hours of energy you utilized for the last May month, we can say. That's what the simple idea. Clear? So what is the meaning of unit means? That is energy consumed. Energy consumed. That is kilowatt hour. Clear? Right. Vallurpalli Srikanth. Sir, how the meter will be stopped? Let us start the meter first. After that, we'll stop. Okay, let us start the meter first. After that, let us try to stop. This is the main headache with the people. When to ask, whether it is to be asked or not. You should have minimum thought. Right. Whatever the energy meter we are going to discuss now, that will show only energy. This is olden day type of energy meter, not the present digital type energy meter. Present day energy meter is digital. In that, all things are working based on the programmable function and what is that LED concept, etc. But we are going to take analog type of energy meter completely. Right. Jadhav Pradeep, kindly ask your power system faculty, because the tariff related question, no, he will explain. But my topic is measurement of energy. But what is the bill? What is the tariff in the power system? Tariff is there. You will get that. So kindly concentrate, sir. In the energy meter, in the energy meter, how many circuits will be there? How many parts? Construction I'm taking. What are the different parts available in the construction point of view? In the energy meter, the construction point of view, right? What are the parts available? What are the parts available? And what are those and all I'm going to take now. Here, the energy meter construction. In the energy meter construction, we are having 4 parts. One is the energy meter consists of driving mechanism. Means based on this only, the entire energy meter function will be available. And rotating mechanism means it is a moving object. Braking mechanism means it is to break the unwanted operations. How? I'll tell you everything. And registering mechanism, it will be registering the values. Sir, what does it mean? Means go back. Sir, this energy meter is having registering mechanism, not the recording mechanism. We say it is registering mechanism. So what do you mean by that? Means very simple. Today, I am consuming the power for 6 hours of time. 1 kilowatt, for example, 1 kilowatt into 6 hours today. Plus tomorrow, 2 kilowatt into 1 hour. For example, right? This plus second day, plus third day, plus fourth day energy, all will be registered. All will be registered. That is called as registering mechanism. Registering mechanism means 1 plus 2 plus 3 plus fourth day, fifth day, like that. Keep on adding. That is called as registering mechanism. But what do you mean by recording mechanism? You know, 1 day recorded, second day also recorded, third day also recorded, fourth day also recorded. At the end of the fourth day, if you see the energy meter, first day value should be visible, second day value should be visible, third day and fourth day value should be visible. But is it visible by the energy meter? No. That's why it is called as registering mechanism. But few places it is given as recording mechanism, but actually speaking, registering mechanism is the correct word. So therefore, in the energy meter, the values will be registered continuously. That is over a month of time or a period of 1 month. Clear? Okay. Sir, what is this? driving. In this driving also concentrate here. Sir, what is that? Power. What is power? V into I into cos phi, because AC. V into I into cos phi means, first of all, in order to get the energy, concentrate. In order to get the energy, we need to get the power first. We need to get the power. That's why in the driving mechanism, voltage and current combinedly, power will be there. Okay, this power will rotate the corresponding system. Therefore, rotating mechanism is rotating mechanism. Clear? After that, we'll be discussing about these two later. No need to worry. What is it? First, in the driving mechanism, voltage related means potential coil will be there and current coil will be there. Combination, we get the power. Due to that power, the corresponding force, we can say, the disc will be rotated. The rotating mechanism means one aluminum disc, lightweight aluminum disc will be there. Very, very lightweight disc. Aluminum disc will be there. Okay. After that, sir, while designing only, if the disk is rotating at more than the rated, more than the proper speed, or if the disk is rotating at less than the proper speed, automatically that speed must be controlled or need not to be controlled. That speed must be controlled. So therefore, the braking mechanism, that's why the speed will be, the unwanted operation will be broken. Broken means not physically broken here. Technically, it is stopped, we can say. It is stopped, we can say. That's what the point here. After that, registering mechanism means power consumed for 6 hours plus power consumed for 12 hours plus power consumed for 15 hours means continuously registering will be there. What is it registering also? I'll be only this introduction. After that, I'll be showing the figure clearly and I'm explaining total things. No need to worry. Right? Okay. Now, sir, what is a driving mechanism? What is driving mechanism? Wherever, see, just I'm showing the figure first. In this, I'll be showing each and every point. For more clarity purpose, I'm taking the figure like this. Now, concentrate here. Kindly look at the cursor, what I'm showing. Look at the cursor, what I'm showing here. Right. Here. This coil is there, no? This coil along with this one connected in parallel. Is that no? Therefore, this is called as pressure coil or potential coil. Okay. What is this blue color? I tell you later. Next, sir, load coil is series. So therefore, series means current coil. Series means current coil. Clear? Okay. After that, sir, this is the spindle. This is the spindle. Okay. Here, bearings I have shown. Tops are also there, but not shown. Top. What is that? Bearings. Okay. On this spindle, what is it? Moving object means aluminum disc. Means I told you this in the corresponding damping torque notation. What is it? This is a spindle. Simply a CD is placed here. Simply one CD will be placed. If it is rotating, CD will be, that's what the arrangement. Clear? After that, this aluminum, that too very, very lightweight disc. Aluminum itself is light material. Okay. Next, braking magnet. It is a permanent. Why permanent? I'll tell you. Only to one side, this braking magnet will be placed. Sir, why? Breaking the unwanted operation. Breaking the unwanted operation. Sir, why also? I'll tell you. Okay. Now check it here. Sir, driving mechanism we have taken. Right? What is the driving mechanism? I told you. Pressure coil and series coil. Nothing but current coil. Both are there. Okay. Next, rotating mechanism, aluminum disc, and braking mechanism. Braking mechanism we have taken. So what is registering mechanism? Don't worry, I'll show you that later. After having the corresponding discussion of these three, then we'll be going for registering mechanism. Finally, we will be getting the corresponding energy value. Clear? Right? But don't worry, I will be spending lot of time on this figure only. No need to worry. Lot of time will be spent, not only for idea purpose I'm showing. Okay, right, sir. Pressure coil is highly resistive or lightly resistive? Highly resistive. But in the energy meter, the pressure coil is made up of highly resistive and also highly inductive. Why? I'll tell you. Here the controversy. Sir, so far in the day before yesterday, you told that, what is it? Pressure coil inductance must be low. Beta should be low. But that is which device? EMMC device, power measuring device. One coil is fixed, one coil is moving there. But here, both the coils, pressure coil is fixed, current coil is fixed, aluminum disc is moving. Means, can we say both are same? Can we say both are same? No. Both are devices only, but that was based on the electromagnetic induction. Current carrying conductor plays in the magnetic field. But here, this is induction principle, that is electromagnet, but this is simple induction. Why? These two coils are fixed coils. That's why, be clear, the EMMC device over. Beta should be low, already low. We have taken questions also. What is beta? Inductive or impedance angle. Nothing but inductance must be low. In the EMMC device, inductance is low, error is low. We have taken so far. Now, in the energy meter, means complete different construction, different working principle also. That's why don't compare. Here I would like to say one more point. Kindly concentrate for both the people, instrumentation as well as IN, because instrumentation people are also having the machines subject. Last year only they have added, but you don't have the total subject of electrical people. See, in the electrical people, generally, for you also, IN also, suppose first machines faculty is taking, for example, DC machines, for example. Okay, you understand DC machine, everything is clear, questions are solved, you are very happy. Okay, DC machine is clear, you are feeling like happy. After that, other faculty or next faculty, induction machines is started. The moment induction machine is started, then you are getting doubts in the DC machine. Then you are getting doubts. Why? Means now you are unnecessarily, irrelevantly comparing both the machines. Irrelevantly comparing. That is the main. That's why where we have to compare, when we have to compare, how we have to compare, that you should understand. Every time DC machine, first topic, there is no idea, everything, simply understood everything. Induction motor, immediate commutator is not to be there. Sir, why DC machine commutator is there? Again, confusion like that, you start getting the confusion. That's why I'm requesting everyone where to compare, when to compare, how to compare. You should know, you should know. That's why here also, how do you compare energy meter with EMMC in every aspect? No, you should not compare in every aspect. Wherever we can compare, wherever the similar operation, similar construct, then we can compare. But here construction is different, working principle is different, application also different. That's why don't compare each and everything. Only where you have to compare, it has two coils, that also has two coils. It is called as pressure, that is also pressure. It is called as second coil, current coil, that is also current coil. Their potential coil 5P, here also 5P. Their current coil 5C, here also 5C. Up to that only. But their potential coil was rotating, moving coil was there in the EMMC. But here potential coil and current coil both are fixed. So therefore, complete construction, working principle and operation, everything is, what is it? It's different only. Clear? Okay. Now I am writing each and every point. So what is shunt magnet? What is shunt magnet? Right. See, wherever I need to write unnecessary, just I'm showing like this. Unnecessary written part, I'm showing like this. Right. Concentrate. But I'll spend much time on this. See, driving mechanism. What is that? Shunt magnet and series magnet, both will be there. I told you, driving mechanism means here, what is that? Potential and current, shunt and series we can say. Okay. Shunt magnet means, what is that? Potential coil. Potential coil circuit we can say like this. Shunt parallel. Series current coil circuit. That is not the point. Right? Right. So shunt magnet, very important point is shunt magnet. Shunt magnet should have highly inductive nature. Should have highly inductive nature. Sir, why? Well, I'll tell you. This is only construction, but why highly inductive? This is very important point. I will clarify. Actually, my topic is purely based on this one. Don't worry. What is it? EMMC device. EMMC device. What is it? Potential coil is low inductive. Potential coil is low inductive. Okay, but in the EMMC, why highly inductive means the manufacturer designed this with highly inductive. Why means some advantage is there. There, L should be low, beta should be low. That is advantage. But here in the energy meter, the L should be high. Therefore, advantage. How sir means different construction, different operation. Yes. Okay, next. All I told you. Potential coil is placed on the shunt magnet and it is directly connected to supply. Check it. Potential coil is connected. Potential coil is connected on the shunt magnet is parallel. Okay, and directly connected to the supply. That only there. Okay, next. PC carries potential carries which one IP. IP. It is proportional to supply voltage only, independent of load. This point is very important point. This point is very important point. So what is it? Potential coil carries obviously. What is it here? IP. IP. This is IC. This current is IL. Again, this current is IC. Therefore, the potential coil is directly connected to the supply. That's why potential coil current directly proportional to V phase. I'm saying that proportional to, not in phase. Don't get confused. Sir, highly inductive is there? No. How it is not in phase here? Current proportional to voltage. That's what I gave you. And sir, whatever the load you are changing, IP will not be changing. Why? I load is changed, IL will be changed, IC will be changed, the drawn current will be changed. The drawn current will be changed. So that's why the IP will be independent of load. IP will be independent of load. This is the complete conceptual notation. Clear? Right? Only construction, just how it actually everything is known, but I'm giving as a note actually, separate note I'm giving. Clear? Okay. Now, what about series magnet? What about series magnet? Series magnet means current coil. Series magnet means current coil. Right. I'm spending much time on it. Sir, series magnet. It is wound on a coil. It is wound with a coil called current coil. Obviously, series means current only. Sir, current coil current. IC related to which one? Load. If load is changed, IL will be changed means IC will be changed. Therefore, current coil depends on the load current. Potential coil current depends on the supply voltage. That's what you have to understand. Okay. Right. What is it? It is connected in series with load and carries the current IC proportional to I load. Proportional to I load. This is what the simple construction part related to these two. Shunt and series. Already it is there, but I'm writing separately. If I'm not writing like it will be looking like something is missing notes. That's why I'm giving all this. Okay. Now moving system. Sir, moving system is aluminum disc. Aluminum is a good conductor. And that too lightweight. That only we are taking. Yes, that is aluminum disc. Moving system. Nothing but rotating mechanism we can say. What is it? A lightweight aluminum disc is used and it is placed on the spindle. Common. Now, the speed of the aluminum disc is proportional to power consumed by the load. Obviously. Why? Sir, based on the load change, current will be changing. Yes or no? Therefore, the speed will be changing. Why? This flux will be cutting. The aluminum. Therefore, the speed of the aluminum disc is completely depending on which load. Definitely. Come on here. In our house, disc is rotating means based on our load it should rotate, or based on its own notation means based on load only. That only I'm giving the point clearly. Here, the speed of the aluminum disc is proportional to power consumed by the load. Okay, proportional to. But people are thinking like, sir, according to the load, disk is rotating means ideal case. I'm not saying that exactly equal. I'm saying that proportional. Load is increased, speed will be increased. Load should be decreased, and speed will be. That's what the point. Okay, right. Next, after that, rotating mechanism. After that, braking mechanism. I told you for which purpose. For which purpose we are using this braking mechanism here? Here. Concentrate. Sir, permanent magnet is used. Why? I'll tell you. Only construction I'm giving. For reducing the rotation of the aluminum disc. Actually, for not only reducing, for modifying the rotation. That is, but writing purpose, reducing we can write. But I will show each and everything clearly one by one. Only I'm giving the note first. After that, the aluminum disc induces the eddy current based on their rotation. Means I told you already the eddy current damping torque applications I gave you. I don't remember or not. After completion of TD, TC, damping torque applications I gave you. Eddy current damping torque is used in PMMC over energy meter now running. Therefore, eddy current will be induced on the rotation. The eddy current cut the magnetic flux of the permanent magnet and hence produces a braking torque. But how? I'll tell you. Nothing but the eddy current cuts the permanent magnetic flux. Thereby, eddy torque, nothing but braking torque will be produced. That braking torque either reduces or modifies. Reduces or modifies. But writing purpose, I'm writing reducing or increasing also. We said that depends on the condition. But as of now, I'm using this one, reducing purposes. Clear? Right? Okay. Now, here only I'm showing the fourth point. What is that? Registering system. Registering system. So what is a registering system? Means in this gearing pinion mechanism is used. Don't worry here. It is not explained. I will explain. No problem. Gearing pinion mechanism is used. This is the simple construction. Why I'm giving all this means you should understand, okay, shunt magnet, series magnet means potential coil, current coil. Both are giving power. V into I cos power. That power related force appeared on this rotating system. Thereby, the disk will be rotating. Suppose if the disk is rotating with more than the proper speed, more than the normal speed or less than the normal speed, we should break that entire speed with the braking system. That's it. After that, registering mechanism. For registering this power into time, register power into time. How it will happen, I'll tell you. This is a simple introduction regarding the total topic. Okay. Now, first I'm concentrating on power. What I told you here, the speed of the aluminum disc is proportional to power consumed by the load. Yes or no? Yes. How that power comes? How that power comes? I'm taking now complete mathematics. I'm taking. I will write everything. No need to worry. Wherever these simple notes or repeated notes are there, I'll give you the typed one. Otherwise, I will write it. No need to worry. Right. People are asking why not copper disc? Copper is a little bit more weight than the aluminum. That's why I'm saying that before answering, think of the question. Lightweight. Aluminum is lighter. Copper is light. Aluminum is only lightweight. Right? Now, deflecting torque. I'm deriving the total deflecting torque. But kindly concentrate. Whoever is having the problem with electricity basics and all will be covered in this for this topic. Be clear. First, supply is given, load is being connected. Supply is given, load connected. IP, IC into picture for a particular load, for a given load. What is it? IP, IC will be there. Okay, sir. IP will be there. IC will be there. Okay. So based on IC, which will be there? Phi C will be there. Obviously, excitation. Based on this phi P, which will be there here? Phi P will be there. Okay. So therefore, based on this phi p, based on this phi c. Okay. Sir, this phi c links the aluminum disc nothing but plate type structure. Due to this, a DEMF will be induced. A DEMF. Due to this also, a DEMF. Why? It is not the normal wire or coil to get the induced. It is a plate type structure. All I told you in the eddy current damping structure. What I told you, eddy current or eddy EMF means these are induced in the core type structures or any plate type structure. Yes, eddy. So therefore, due to this eddy EMF, due to this eddy EMF, but understanding purpose, eddy EMF due to potential coil flux, eddy EMF due to current coil flux. After that, sir, wherever the eddy EMF is there, wherever the eddy EMF is there, automatically eddy current will be there. Yes, IEP, IEC, eddy EMF and eddy current will be there. Okay. Now, very important. I think Mubin, this question asked, I clarified, but I'm repeating for everyone. What is it? Sir, on the aluminum disc, right? Come on the aluminum disc, how many currents are there now? Two eddy currents are there. IEP, eddy current due to potential, eddy current due to current coil. Okay. Now, sir, current carrying aluminum disc placed in the magnetic field, right? Current carrying aluminum disc placed in the magnetic field. Current carrying aluminum disc placed in the magnetic field. Current carrying aluminum disc placed in the magnetic field. It experiences a mechanical force. But many people are having that thought like, sir, why are you taking IEC to 5P? Why can't you take like this? Means this is the self flux. No one conductor, no one body, no one physical structure will experience a force due to its own flux. No, never. Due to its own flux, the corresponding force will not be produced. This is not my measurement. This is the electrical concept basic. IN people basic. Kindly more care. What is it? In order to get the force, right? Current from one body, flux must be from other body. Then only we get the force. Otherwise, simple logic. Transmission line is there in front of your home. One line is going, distribution line. Okay. Due to that, surrounding that conductor, flux is there. Conductor is there, current is flowing, flux is there here. Can we say current carrying conductor placed in the magnetic field? No, this is its own field. It is not placed in that field. Due to the current flow through that conductor, field is existing. That is the reason why we should not take same flux notation, other flux only. Okay, therefore, in this, how many will be there? TD1 is related to TD2 related to nothing but how many torques? Two torques, obviously. One force, other force. One force I'm taking as phi P and IEC. Other force I'm taking phi C and IEP. Phi C and IEP. Okay. Why? Current carrying conductor plays in the magnetic field. Current carrying conductor plays in the magnetic field experiences a mechanical force. But be clear, see, IEC to phi C, we cannot take. Why? That is called as self-flux, self-magnetism. No force at all. Yes, so therefore like this. One thing. Sir, what is the TD1 proportional to? Sir, phi P, everyone concentrate, phi P. IEC, okay. Is it AC system or DC system? AC system. That's why the two, what is it here? The torque produced on the aluminum disc is proportional to power. Power means V into I into cos phi. So how do you say that means? Concentrate here. I told you, first we need to concentrate on power. Once we get the power, we can go to energy. That's it. So therefore, I'm taking here 5P. P, everyone, P, potential voltage. C means current. So indirectly, V into I concept only there. V into I concept is only there. So therefore, what is it here? Cos of phi P and IEC. phi p and IEC. Right after that, TD2 proportional to phi c IEP, phi c IEP, cos of what is it here, phi c and IEP. Clear, guys? Right. Up to this, clear or not? Can you let me know? Gagan, I have not started the braking magnet so far, right? I have not started the operation at all. Only construction, what will be there, I told you. Right. Clear, guys? Okay. Right. Why we take cos phi? That's why I'm saying that listen carefully. After the explanation, same statement related question, kindly don't ask. I told you phi p voltage, C current, V into I. This is the AC system. Torque is proportional to power. Power means V into I into cos phi because it is AC, not the DC. AC means V into I into cos phi. V into I into cos phi. That's why automatically AC means we should take V into I into cos phi. Vishwani, clear? Right? If you don't take cos phi, that implies okay, DC circuit. No, it is perfectly AC. So automatically, what is that? V into I into cos phi. That is what? AC notation. Okay, next. IEC what? What did you do while I was explaining? What did you do? Eddy current due to the current coil. Eddy current due to the potential coil. Potential coil, potential coil, potential coil, potential. But this is the main current flowing through the coil. This is the current flowing through the aluminum disc. Eddy current. Aluminum disc, eddy current. Got it? Okay, sir. Now we need to find out the phase angle between these two. How? Complete phasor diagram with the basic idea, everything I'm going to derive because in the derivation only some concept is there. After that, after the break, we'll continue. Only equation formation I give you, but from this phasor diagram and then totally conclusion, everything will be there. After that, operation is very, very simple. Right. Can you take the break and come back? I'll continue. Right. Come back. Right. Let us continue. How to determine the phase angle between these two? If phase angle is there, we can proceed easily. Now let us take the phase angle, that is phasor diagram. Concentrate here. I'm taking two figures separately to have more clarity. Concentrate. Sir, I'm taking VL is equal to V phase reference I'm taking here. So how can you take VL equal to V phase? All I told you in the last class. In the EMMC operation, I told you VL is equal to V phase. Sir, how? Means I'm showing again, don't worry. Sir, in this is V phase. This is VL, voltage across load. Sir, this voltage is appeared here. This voltage is across the current coil appeared. But current coil drop is very, 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 very less. So therefore, I told you, yes, both will be equal, I told you. Clear? First point. So V phase equal to VL, first one. So generally, in our domestic application, in our house, loads will be more of lagging only. Leading loads generally not possible directly. So therefore, simply I'm taking as a load as a lagging load example. What is that? Here. This is IL lagging by some 5 degrees. So why only lagging means I'm assuming lagging load. Generally, in the domestic application, mostly, not only domestic, mostly loads are lagging loads only. Same thing I'm drawing here. So why 2 times? I'll tell you. This is IL. What is the angle? 5. After that, sir, IC and IL. IC and IL both are same. So therefore, what we can write now? Sir, IL is equal to IC. IL is equal to IC. Okay, now very, very important point. Sir, IP lags the V phase by large angle or small angle. IP lags the V phase. See, this is IP, the potential coil current. Lags the V phase by large angle or small angle means large angle because the potential coil entire circuit is made up of highly inductive. That's why, be clear, I gave the note already here. I gave the note already. Shunt magnet is highly inductive. Shunt magnet is highly inductive. But sir, how it is happened means, concentrate guys. Sir, here this potential coil is highly resistive is there, low inductive is there, and this copper shading band, this and copper shading band or copper shading coil we can say. That's why, be clear. This is the potential coil, highly resistive, normally low inductive we have taken, plus copper shading coil also connected like this, right? This is highly inductive. So what is the total coil structure now? Highly inductive. Why? Already low inductive added with highly, therefore highly inductive. This is actual structure, but for clarity purpose in the figure we show like this only. What is it? Here some boxes type we show, but that is a coil type structure only. Therefore, by adding the copper shading band, the entire potential coil is made as highly inductive. Therefore, IP lags the V phase. IP lags the V phase by large angle. IP lags V phase by large angle. So how much is the large angle? Means always we try to make this potential coil as pure inductive. We try to make potential coil as pure inductive. But why do we try? I'll tell you. Proof I'll give you. But we try to means manufacturer. Try to manufacturer tries to make potential coil as pure inductive. But is it possible with pure inductive? Practically no. That's why almost pure inductive means near to pure inductive means what is that angle here? 90 degrees lagging or near to 90 degrees practically. That's why concentrate here. IP lags the V phase. IP lags the V phase by which angle? Delta. This delta is approximately 90. 85, 88, 89, like that will be there. 85 above only will be there. Why? I told you, this is, what is it here? Manufacturer tries to make this as equal to 90 degrees lagging, but 90 degrees lagging means pure inductive. Pure inductive is not possible practically. Okay, leave it. That's why I'm taking almost 90. This is 90 line now, so almost 90. Same thing I have taken, same thing I'm taking here also. This is IP, this angle is delta. Okay, after that, sir, the moment IP is there, phi P will be there. The moment IC is there, phi C. Sir, where will be phi P? Sir, phi P will be in phase with IP or lags with IP or leads with IP. Phi P in phase with IP, lags with IP or leads with IP. That's what the very, very, very important point. Always phi and current will be in phase. Sir, why? I'm giving the electrical basic principle also. Instrumentation people, it is more useful to you also. Concentrate. Sir, it is in phase. People are giving lagging, leading, all options. Kindly concentrate here. I is equal to Im sine omega t is a current equation. Due to this current, flux is there. Which current? IP or IC, anything. So therefore, I'm taking. What is the formula? Sir, flux is equal to MMF by reluctance. Basic formula. Okay. Now I'm substituting N by S. What is I? Im sine omega t. Im sine omega t. Okay. After that, sir, from this, what I'm writing, N Im by S sine omega t. Sir, what is it? Phi is equal to phi m sine omega t model. But can we write this as phi m? Yes, definitely. Why? N I by S is phi. N I m by S is phi m. Therefore, phi is equal to phi m sine omega t. Be clear. This is the flux. This is the flux due to this current. Therefore, check it. Im sin omega t, phi m sin omega t, no angle. Therefore, what we can write here? Phi is in phase. Phi is in phase with I. This is a proof. Blindly, I'm not giving here. With proof only, I'm taking this entire discussion. Right? Okay. Now I'm going back. Sir, IC is there. Phi C will be in phase with that. IC is there. Phi C will be in phase. Okay. Next. Sir, phi P, IP is there. Phi P will be in phase. IP is there. Phi P will be in phase. With the proof I'm giving, kindly don't ask again how it is in phase. Already I proved it. That's why each and every word, each and every letter must be concentrated. Clear? Okay. After that, what is there here in this? Here, IP over phi P, IC, phi C. These four are over. Which is there? Due to phi P, E will be there. EEP. Due to phi C, EEC. Means due to phi DEMF will be there. EMF will be there. What is the relation? Now tell me. Here, where will it be? Phi P over phi C over. Now EEP, where should it be? EEP, lagging or leading or in phase with these three, with these two. That's what I'm taking now. Again, sir, E is equal to minus n d phi by dt. Okay, minus n d by dt of this flux only inducing the EMF. So therefore, phi m sine omega t. Phi m sine omega t. Okay, right, sir. Minus n phi m. I'm taking outside. D by dt of this. What is that? Omega cos omega t. Omega cos omega t. Okay, n phi m omega minus cos omega t. I'm writing like this. Okay, after that, n phi m omega minus cos omega t can be written as minus cos omega t can be written as which one here? Sine omega t minus 90. After that, this I'm writing as em because e into e maximum. No. Therefore, e is equal to em, some magnitude, no worries, sine omega t minus pi by 2. Sir, this is the induced EMF. This is the flux. Now tell me, flux is sine omega t. Induced EMF is sine omega t minus pi by 2. Therefore, what we can say? Induced EMF lags the flux by which one here? 90 degrees. Lags the flux by 90 degrees. This is completely basic electrical only, but to have the my topic clearly, I'm taking all this. Okay, now induced EMF lags the flux by 90. No, yes. Here I'm taking, concentrate. Here I'm taking, here, concentrate. I'm taking EEC. I'm taking. Sir, how? Check it. EEC lags the phi C by 90. Okay. In this figure, I'm taking EEP means for more clarity, I'm taking separately. That's it. That is the reason why I have drawn two diagrams. This is EEP. Sir, induced EMF lags its own flux by 90 degrees. Over. After this, finally, go back again. Sir, EEP is over, E is also over. Which is left over now? IEP, IEC. Concentrate here. EEP induced on the aluminum disc. IEP also produced on the aluminum disc. Aluminum is a conducting material. Yes or no? The two. Once the flux is cut by the conductor, that is acting as magnetic circuit. Magnetic circuit means simply RL combination. RL combination means I lags the EMF. I lags the EMF. How much angle we don't know. That depends on the aluminum nature. What is a material, dimensions, everything will be taken. So therefore, finally, what we can say here, sir, this is IEC. We don't know alpha. Everyone concentrate. Alpha depends on the aluminum material. How we are making the aluminum, how much dimension, how much thickness, and everything. So therefore, aluminum acts as a aluminum is a conductor, but after the flux is cut by that, it becomes a magnetic circuit. Magnetism means coil system. Coil system means inductive nature. So automatically, IEC lags EEC. Same time. What is it here? IEP lags its own EEP by alpha. Now the doubt is, sir, this alpha, same or different? Same only. Why? Same aluminum, same aluminum disc is same only. That's why alpha is same. This is what the total phasor diagram, step by step, with the proof I explained. Clear? Okay. Now, what we require? Angle between phi p and IAC. Angle between phi p and IAC. So what is phi p? What is IAC? Check it here. Phi p, IAC. This angle we require. Okay. Now second angle, phi C and IEP. Phi C and IEP. Phi C and IEP. Okay. Now what is this angle? Very simple. After this, simple. 7th class, 8th class, 9th class topic only. What is it? Concentrate. Sir, start from here. Alpha plus 90. But 90 means up to this. But we require up to this only. Therefore, 90 plus alpha minus this portion. 90 plus alpha minus this portion. What is that portion? 90 plus alpha minus this portion. What is that? Delta minus 5. Delta minus 5. Clear? After that, sir, here alpha plus 90, but we are here only. We need to go up to this, means this plus this value. So therefore, in this exactly opposite, what is that? 90 plus alpha plus delta minus 5. This portion is delta minus 5. In this we need to add, in this we need to subtract. That's what the point. This is a total phasor diagram with the concept. This is the concept, and then this is a phasor diagram. In order to understand this again, corresponding mathematical concept. Right? Now, let me proceed now. Mathematics again. Sir, TD1 proportional to 5p IEC cos of 5p IEC cos of TD2 proportional to 5c IEP cos of. Right? Now what is this? Here. What is that? 5p and IEC. 90 plus alpha minus delta minus 5. 90 plus alpha minus delta minus 5. Here 90 plus alpha plus delta minus 5. Right? Now, people are asking, sir, why sign have changed? Right? Diagram is different. No, sign will be different only. Come on here, concentrate. I told you, no, like this you measure. Here minus will be there. Here plus will be there. Why means see the phasor diagram. Before asking the question, kindly go to that. That's why move along with my, what is it? Indication cursor here. No, alpha plus 90. Here you are having. Is it no? This portion must be subtracted. Why? You require up to this only. And alpha plus 90. You need to add this portion because you need to get this one. Clear? Okay. Now, after this concept, sir, two torques are there. Okay. But what is the resultant torque? Kindly concentrate. IN people take it for granted. But electrical people, you will be having the same concept in the induction machine. That is, what is it? Double field revolving theory, because one field and the second field. What is a double field revolving theory? Based on that, everyone consider in the construction side also, the resultant torque is equal to TD1 difference of TD2 only. Everyone, no one should get the question like why the difference. This is the double field revolving theory concept. Two torques will be there. Difference only will be taken. According to that only, in the energy meter, coils will be placed. That will be designing stage. No need to worry. Therefore, TD1 difference of TD2. Now it is your duty to substitute TD1, substitute TD2 and simplify. But, sir, can we say this as simply voltage? Why? Yes, 5P. P means potential voltage. What does it mean? Voltage concept. IEC, C means current. So V into I. Okay. Now 5C, C means current coil flux. So current concept. IEP, P means potential voltage. Nothing but 5P depends on V. 5P proportional to V. IEC depends on I only. 5C depends on I. IEP, V. Here confusion will be there. I'm repeating. Concentrate. 5P, P potential voltage. Potential means voltage. IEC, C means current I. 5C, C means current. IEP, P means potential. That's why VI you can take common. Anyway, we are going to write proportional notation. No need to worry. So therefore, simplify this. You are going to get V into I common. right? If you simplify this, you are going to get some term sine delta minus phi. Otherwise, you can write proportional to equal to. No need to worry. No need to worry. Right? What is this value means? Kindly, I'm giving this as a homework. 2 sine alpha or 2 cos alpha, which is there, you need to tell after practicing. You simplify this, either this will be there or this will be there. Don't say that, sir, you have written both. No, I'm giving the question. Simplify this because cos c minus cos d, cos c plus cos, like that. You simplify that, you will be getting some term. Sine alpha, cos alpha, you need to decide. I'm giving just practice purpose. Okay, after that. Okay, any term. Sir, alpha, everyone constant. Alpha for a given energy meter is constant or variable. For a given energy meter, alpha is constant or variable. Come on, alpha is constant. Sir, why? Go back again. Sir, alpha means aluminium. Alpha is nothing but aluminium current and voltage angle. Aluminium material, current and voltage. Aluminium is same aluminium. Are we changing the aluminium while during the operation, etc.? No, same aluminium material, same thickness, same dimension. Automatically, alpha is constant. That's why, as the alpha is constant, finally we can say, what is it? TD proportional to V into I into sine delta minus phi. Sir, the torque produced on the aluminum disc is proportional to the torque produced. Very good, sine alpha. But I'm giving the work. So the torque produced is proportional to power consumed, I told you. Yes or no? But power consumed, what is that? VI cos phi. But VI cos phi is true power. But this is which power here? Measured power. Why? Everyone try to understand my terminology. Torque produced on the aluminum disc. Torque produced on the aluminum disc means, will it be coming under measured power or true power here? Measured only. Why? Torque produced on the aluminum disc gets rotated. Based on the rotation, reading will be there, means measured value. That's why with this entire discussion, therefore finally measured power is V into I into sine delta minus phi. I have got it with the proof only cos c minus cos d formula I've given as a homework. Okay, after that, yeah, many people are giving that sine alpha. Okay, right. Now the point here is, this is measured value. Everyone knows that, sir, what is the true value? Obviously, V into I into cos phi only true value. Very simple. Now let us find out the error. Therefore error is equal to, error equal to Pm minus Pt, Pm minus Pt, Vi common, sine delta minus phi minus cos phi. Suppose if I want to calculate percentage error, what is that? Pm minus Pt by Pt into 100. Okay, what is that? This entire thing by Pt. VA cancel. What is the value? Sine delta minus phi minus cos phi by cos phi into 100. This is percentage error. Okay. Now concentrate here. First point, among these two, which is more and which is less? Respond kindly. Which is more among these two? Measured power will be more or true power will be more? Among these two formulae, you can answer mathematically. PM is more or less? Come on. Right. Mathematics I'm getting, but can't connect, sir. What is Ashish? Only I'm taking mathematics only. I have not started the concept yet. Only mathematics I'm taking. After this, I'm going to the concept. Sir, here PM is greater than PT mathematically only. Mathematically only. Sir, why? Sir, why? Sorry. PM is less than PT. Sir, why? Concentrate. Sine delta minus phi cos phi. But what is delta? I told you less than 90. Okay, let me take 85. Sine 85 minus phi definitely less than sine 90 minus phi. That is cos phi. So automatically measured power is less. The measured power value is less only. But people are given wrong answer also. PT is less. Come here. For a given value, this is 45, cos 45, sine 85 plus 45, sine 45, cos 45, which will be less here. This only, your mathematicians, come on, PM is less than PT. Okay, right. Sir, error will be this much value, VI sine delta minus, etc. Sir, very important note. Now I'm giving the concept here. So far I have taken only mathematics. Don't worry, only mathematics only I have taken so far. Okay, now everyone concentrate. The next 15 to 20 minutes topic is very crucial. If you don't listen that, kindly forget about the energy meter. Don't ask the doubt. If you don't listen, next coming 15 to 20 minutes, keenly, without typing anything, you don't understand that, simply leave the energy meter. Don't ask any doubt. If you don't listen, kindly concentrate. So first point, error is there or not? Definitely error will be there. Practically, some load is connected. Due to this load, the disk is getting rotated. Due to this disk rotation, the reading will be shown by the meter. Which one? Power measured, I'm saying. So therefore, that power measured value is less than the true value. Why? Due to the practical condition, less. But my question is, sir, in order to say, difference is there? No, yes. In order to say error must be low or percentage error must be low. Now tell me, how do we get it? How do we get it? Means be clear. Phi in the load operate notation. In the manufacturer side, so delta is 90. If delta is 90, sine 90 minus phi cos phi minus cos phi, sine 90 minus phi cos phi, cos phi. Bhaskar, kindly leave the session. Don't attend the class. Right. See here, sine 90 minus phi means cos phi. Cos phi minus cos phi, 0. Error is 0. Error is 0. Means if the delta is 90, concentrate here. If delta is 90, error is 0. But if delta is 90, error is 0. But which one? Ideally. Why? Error is 0. Ideal. Delta 90 is also ideal only. Sir, why? Delta 90 means the potential coil circuit must be purely inductive, which is not possible. 1 point. That's why practically what we can write now, therefore delta is approximately 90. That is approximately, what is it, greater than 85 is it. Then error will be less. Now tell me, in the shunt magnet notation, I told you highly inductive. Therefore, the highly inductive nature is required or not required? Required. How do we get that highly inductive? Means all I told you, by adding copper shading band. That's why I told you here. Potential coil, concentrate guys. Potential coil and copper shading coil like this. But for clarity purpose, we show differently. But actually potential coil and copper shading coil like that we can show. So therefore, due to the connection of copper shading coil, what is it here? The entire coil is getting highly inductive. Highly inductive means highly inductive means the delta will be near to 90. If the delta is near to 90, error will be near to 0. Error will be near to 0. This is what the actual concept of or actual reason of making potential coil as highly inductive. But same topic we have taken the EMMC. There we proved that potential coil inductance must be low, beta must be low. Why? Construction operation is different. In this also, without the proof I am not giving here. After taking the entire proof only, approximately equal to 90. So therefore, what is that? Error will be almost 0. Yes, error will be less. We can say very, very less. That's why in the energy meter, definitely the potential coil must be, definitely the potential coil must be highly inductive. That's why I gave you shunt magnet totally highly inductive. Shunt magnet totally highly inductive. That's what the point. Clear? Why the shunt magnet or why the potential coil is highly inductive in this energy meter? While the potential coil in the EMMC is very low. I give the difference. Kindly try to understand. Okay, now I'm taking the procedure. But before going to that, be clear, guys. Concept, every point, 15 to 20 minutes of topic. I told you, no, very important. This is one thing. After that, sir, PM is less than PT. With this entire mathematical proof, lagging load only. What is that? PM is less than PT. Right. My question is, sir, concentrate. If PM is less than PT means measured power, with this measured power is less than the true power consumed. Sir, what we can say? Measured power is less means the rotation is less or not. Why? Based on the revolutions only, we are getting the measured value. Measured value is less means the speed of aluminum disc is less. If the speed of the aluminum disc is less, automatically less revolutions, automatically less energy shown. But is it acceptable technically? No. Means load is more, but reading is less. Not acceptable technically. That's why we need to increase the disk speed. For a given load, concentrate here. For a given load, the disk is rotating less than the normal speed for this corresponding load. So therefore, concentrate here. How could we say that? Means I'm coming again, sir. PM, I'm repeating here. PM is less than PT. What does it mean? What does it mean? Measured value is less than the true power consumed. Means the rotation of the disk is less than the normal speed what we require. Therefore, the rotation is less means as the manufacturer, what he has to do? Okay, rotation must be increased. Means rotation must be modified, we can say. Increase. How will it be done? Means by connecting this braking magnet. That is permanent magnet. Who is connecting? Manufacturer only. Manufacturer. What did you know? Can you look at me for 1 minute? Look at me. This is the disc. This pen is a disc, right? Disc is getting rotated with less speed, little bit less than normal speed, but not acceptable. Therefore, how do you increase the disc speed? Means people are saying that, sir, increase this 5p, increase this 5c. Come on here. For a given load, for a given supply, only we have got it. We cannot increase this. We cannot increase this because for a given load and for a given supply is our topic. That's why other thing, what they do, you know, simply they will take one. Kindly look at this. This is the disc. They will keep the permanent magnet like this. Suppose if the permanent magnet is like this much of flux is cutting. Therefore, flux cut by this aluminum disc from the permanent magnet is coming into picture. So automatically what happens, sir? Flux cutting will be increased on the aluminum disc. As the flux cutting is increased, what is it here? The disc speed will be increased. Whatever the reduced value is there, that must be increased. How do we check it? They will check it here like this. Simply they will move like this, they will move like this, they will move like this, keep on moving here and there. They will check it. Okay, at one place, at this place, the disc is properly rotating. Disc is properly okay. At this point, this entire thing will be bolted to the corresponding box. Means this will be fixed. That's why be clear. The braking magnet is breaking the aluminum disc speed or not? Yes. Okay. People are asking one more doubt. Sir, if this permanent magnet is kept like this, by whom? Manufacturer only. Okay. he is kept like this. Suppose he is keeping. So after keeping this position, if the speed is more, no problem. That's what I told you. Like this and like this, they will check the speed where we are getting the proper speed, where we are getting the proper speed. At this point, they will fix it. At this point, they will fix it. Okay, right. Now, the braking magnet should be permanent magnet or electromagnet. What is the point here? If it is electromagnet, for example, if it is electromagnet, for example, what happens here? This permanent magnetism varies with the supply, varies with the time and supply. Therefore, permanent magnetism is varied. Flux linking the disk is varied automatically. The speed may be increase, maybe decrease, maybe increase, maybe decrease. We don't know. But what should be there? What should be there? Here, from this magnet, constant flux is required. Then only we can say, yes, okay, this is the load, this is the speed. Okay, I'm keeping here means constant flux. Constant flux means from the permanent magnet, constant force that will be adding to the disk and getting rotated. That is the reason why to have constant magnetic field, independent magnetic field, that is simply permanent magnet. Always we use permanent magnet for breaking the unwanted operation. Okay. One more thing, sir. The generally people are asking, sir, can we operate this permanent magnet? People are asking. Suppose in the fun way I'm giving, if this permanent magnet is operated by the operator, where will be the permanent magnet? Permanent magnet will not be in the instrument. We'll take out, we'll keep it in our pocket. Why? Means if this permanent magnet is not there, automatically due to this, flux will be reduced. Now, correspondingly, speed will be reduced. Automatically, meter reading will be less. That's why this permanent magnet is manufacturer operated only, not the operator operated. So they're not the user operated. That's why they will do like this and they will modify and they will fix it. Now, disk is rotating properly. Disk is rotating not 100%, but better, properly we can say. Okay. So far we have taken only power based corresponding rotation. That rotation is somewhat different. That's why modified. Now, the final point. What is that? Operation. Nothing but energy. How the energy comes into picture? Kindly, everyone be clear. This is given to which one here? Registering system. I told you registering. Actually, registering system means gearing pinion mechanism. We say gearing pinion mechanism means this will be connected to one box. In this, some gears will be there. Some gears. What do you mean by gear? A wheel with number of teeth like this. Old Indian technique I'm giving. Simply number of teeth. Dials also we can say. And one more different techniques. One of the techniques I'm taking. One more, some number of teeth are there. One wheel will be there. So 4 or 5 wheels will be there. So my question is, sir, if it is rotated based on the touching point of this, it is also getting rotated or not? Yes. But my question is, sir, 3 gears are there. 3 gear wheels are there. If it is rotated by 10 revolutions, it should rotate by 1 revolution. Is it possible or not practically? Definitely it is possible. How? By the dimensional change, etc. That's why this disk is getting rotated by 10 times. It will make 1 rotation. If this is getting rotated by 10 revolution, it should make 1 revolution. That is whatever decimal system. That's whatever decimal system. So automatically, what is it here? Our decimal system also 1:10 notation only. Yes or no? Therefore, here below this meter reading will be available. Old Indian technique, not nowadays new. Old Indian technique only I'm taking. So meter reading will be there. Okay. So therefore, somehow, what is that? Either teeth change, or diameter change, anything. Simply 10 revolutions to 1, 10 revolutions to 1, 10 to 1, 10 to 1 will be there. So therefore, concentrate. It is rotated by 1 will be there. It is rotated by 9 will be in the meter. If it is rotated by 10, do you have 10 here only? No. It will be going back to 0. It will be rotated by 1. That only we observe in the bike reading and etc. Same thing will be there. Like that. If it is 99, for example, 100th revolution means it is getting the 10th, 0. It is getting the 10th, again 0. It is getting 100. That is what the gearing pinion mechanism arrangement. Gearing pinion mechanism arrangement. Okay, that type of arrangement is there, which is designed by the manufacturer. Okay, now what happens? I'm giving the complete operation now. Right here. Concentrate. So far I have taken what is the function of brake magnet. If anyone is having the doubt what is the exact function of brake magnet, kindly watch the recorded video, because I have taken almost 3-4 times I explained so far. Okay, right, come back. Sir, in this, gear is rotated by one. Okay, gear is rotated by two. Gear is rotated by 3, like that. For example, if it is showing 1, how can we say this is 1 kilowatt hour? How can we say this is 1 kilowatt hour? Generally, already I told you, first only I asked, where I asked, here I asked you. What is it? 1 unit means 1 kilowatt hour, and the energy meter number 1 means 1 unit, number 2 means 2 units, means 2 kilowatt, 1 kilo. So my question is, how do you say this is 1 kilowatt? Means that depends on the calibration technique. What is that? Everyone kindly concentrate. Last point, that is the working operation. With this, everything will be done. Now, how the energy meter is tested, how the energy meter is designed means, concentrate here. They will keep 1 kilowatt load testing purpose for 1 hour. 1 kilowatt load for 1 hour. Okay, sir, 1 kilowatt load is connected for 1 hour. Okay, well and good. Sir, what they do means, by connecting this load for some time, I'm taking 1 hour, they will assume the number of revolutions. What is that? 1000 revolutions, for example. Sir, why only 1000? Example. Okay, they will connect 1 kilowatt load for 1 hour of time. They will count the revolutions, 1000. Switch off the supply. Okay, sir, this is the energy meter giving the 1000 revolutions for 1 kilowatt load for 1 hour time. Okay, right? How much load? 1 kilo. How much should be shown? 1. Means how much should be the setting of the device here? The setting of the device is here. 1000 revolutions of the disk should be given as 1 rotation of the gear. That is a physical connection that will be taken care by the manufacturer. Kindly don't research. So this is easiest method I'm giving. What is it here? 1000 revolutions are made by the disk. Okay, they are counting 1000. When 1000 revolutions are made by the disk, when, what is it? Supply given is 1 kilowatt for 1 hour of time. Okay, 1 kilowatt for 1 hour means on the energy meter reading 1 should be there. So that how the setting should be there? That is 1000 revolutions to 1 rotation. If it is rotated by 1, yes, 1. That is what the point. That's why this is called as meter constant given to the device. Meter constant given to the device. Okay, one more thing. Second experiment I'm giving. After this, they will be taking some, for example, 2 kilowatt for 1 hour. How much number should be there? 2. Okay, 2 kilowatt for 1 hour. How much energy, how many revolution will be there? Ideally speaking, what is it? 2000 will be there. Sir, 2000 revolutions by 2 rotations. Yes or no? That's why 1000 revolution to 1 already set. 2000 means 2 rotations. Means it is rotated by 2 means number will be 2. Number will be 2. This is what the complete designing stage. But in the first test or second test also, meter constant is 1000 to 1, 2000 to 2. So what is the answer? 1000 only. That's why for a designed energy meter, meter constant will be same or different. Same or different means the meter constant will be same only. That will be decided by the manufacturer. In this way, the corresponding energy meter is designed. Clear? After that, this device is ready. Now check it here. Sir, 5 kilowatt is connected for 5 hours, for example. 5 into 5, 25 kilowatt. In this, 25,000 revolutions, 25 rotation. So 25 will be there. That is what called as meter constant. K is called as meter constant. Therefore, be clear, the total meter reading will be based on the meter constant only. The two, for a given device, meter constant will be, for a given device, meter constant will be, come on here, for a given device, meter constant will be constant always. Okay, immediately, let me complete, Yugasri, let me complete. Okay, sir, immediately people are asking that, sir, if the load connected is 2500 watt hours, for example, nothing but 2500 watt, and what is it, hours, what is that, 2.5 kilowatt hour. Come on here, whatever the gears are there, no, they will be deciding like, what is that, reverse notation. If the decimal point is there, it will be rotated in this category. Therefore, 2.5 will be shown, decimal point will be commonly coming. So that's why they will give, this is the cutoff limit, decimal point will be there. If 2000 watts is given, it will show 2.00 like this. If 2.5 is given, 2.5. In that way, the mechanical gearing pinion mechanism will be set by the manufacturer, designed by the manufacturer. No need to worry. If you understand the normal number, decimal number will be commonly present. But generally, so decimal number small confusing. Simple concept. Yeah. Here, higher side increasing. Here, it is lower side increasing. That's what it is getting rotated. It is getting rotated. In that way, same thing is happening. But how this physical arrangement, no need to worry, I'll be explaining this in terms of digital mode very much clearly in the digital altimeter. But as of now, what is that? Gears are rotated 1 is to 10 is to 1, 10 is to 1, 10 is to 1. Here also decimal 10 is to 1, 10 is to 1, 10 is to 1. Like that, the values will be available. So that's why decimal point will be there, my Yugasri. Don't worry. Decimal point will be there. Yes, accordingly. Yes, that will be wrong. That's why I told you. Meter constant is set by the manufacturer, but this is completely physical arrangement. That is simply designing stage. That much mechanical construction is not required. This is the simplest way of understanding the topic. Clear, guys? So this is a total explanation of energy meter construction, mathematics, and due to that mathematics, based on the mathematics, we understood that the measured value is less. Therefore, as the measured value is less, how can you modify? Means, what is it here? Braking magnet. Braking magnet purpose is, one student asked that, what is the actual purpose of braking magnet? Means it is to break the unwanted operation of the corresponding energy meter. Means, suppose if it is reduced, if it is rotating in slow speed, increase it. Increase speed, reduce it. That is what its purpose. That's why always it has to be breaking the corresponding unwanted operation. That's why during the designing for a particular load, they will test it. Okay, the braking magnet should be here, 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 etc. They will fix it. That's why the name itself is there. Braking. Braking means braking magnet. Name itself is breaking the unwanted. Breaking the unwanted. Ayyappan, yes, that is the next topic. Next topic is that only. Right. Generally, see, usually braking magnet, Manivannan, right? See, usually braking a permanent magnet is used to reduce the rotation of the disc. That's what, when the disc speed is high, it will be giving the corresponding reduction. That's why I told you here the disc purpose is to break. To break, what is that? If the flux is added, if the flux is reduced, based on that the speed can be increased or the speed can be decreased. That's why it is breaking the unwanted operation. But idea purpose, I told you clearly here, simply reducing. I gave you one of the method. Actually, I told one more part also, reducing or increasing based on the corresponding requirement. That's why it is to break the unwanted operation. That's it. And Bhavani, how increased speed is braked, sir? Actually, very good question. How the increased speed is braked means, concentrate here. Suppose if the speed is more, concentrate. You are missing. Actually, this is a Lenz's law topic. Concentrate. If the speed is increased, due to this increased speed, right? Whatever the permanent magnet flux is there, no, flux will be cut by this. Due to this flux cutting, a DEMF will be induced. Due to which one? Due to the increased speed, permanent magnetic flux will be there, and due to that eddy EMF will be there, due to this eddy current will be there, due to that some flux will be there. Sir, this is a resultant flux. This is the resultant flux opposes the main cause producing it. Opposes the main cause producing it. Therefore, whatever the increased flux is there, reduced. How? Speed will be reduced. Therefore, flux will be reduced. Normal speed will be maintained. But it is not clear. I know. Second explanation also I'm giving. Sir, speed is reduced. Speed is reduced. Actual topic I'm giving. Speed is reduced means the flux cutting is reduced. Yes or no? Due to this eddy current, eddy EMF, flux will be there. No, this flux will be opposite this. What is it? This resultant flux will be opposing the reduced flux. Sir, come on, come on. It is confusing word. This resultant flux is opposing the reduced flux means increasing the flux only, right? How? Lenz's law. This flux must be increased. How? The speed will be increased. Automatically, based on the flux notation, speed will be increased. That is what is it? Breaking the unwanted operation. But I have taken only one concept. But due to the practicality, etc., if speed is increased or speed is conceptually we take. Practically, we don't have that problem. But practically, conceptually, if the speed is increased, how to reduce means permanent magnet is already there. No, yes, it will be reducing and maintain the normal speed. And if the speed is increased, reducing, speed is decreased, that's why it is having the regulatory operation. It is a regulatory operation. Very good. Yes. General doubts are in a transformer EMF induced primary due to. Yes, very simple, very simple. Right? Okay. Sharath, I'll come to that. I'll come to that later. That is mal operation. I'll come to that later. So this is what the point. Right? And here, I hope it is clear. Simple logic here. The permanent magnetism increases the permanent magnetism increases the speed when the speed is low. The permanent magnetism decreases the speed when the speed is high. That is what? Regulatory action. Right. I'm specifically asking this point, clear or not? Actually, if you understand the Lenz's law, if you know Lenz's law, it will be clear actually. Obviously, that depends on the manufacturer. 10 years, 20, 30 years will be there actually. Can you respond? Clear or not? Right. No. And one more hint also I'm giving for especially electrical people. If you understand my topic in your synchronous machine, hunting concept will be there in the alternator, etc. Damper bars use. Same concept you are going to study there, but that is more in-depth. That's why my topic will be basic point to understand that synchronous machine topic. Crystal clear. So thank you. Yes, starting synchronous machines. Yes. For a given load, the flux should be constant. For a given load, the flux magnitude should be constant. That is what the actual theory. Very good. See, permanent magnet flux is not varied here. Anil, Kaleponil, permanent flux is not varied. Permanent flux linking, permanent magnetism is increasing the speed, decreasing the speed. See, this flux means this is the flux linking the disk, not the permanent magnetic flux. Permanent magnetic flux is constant only, but flux linking will be increased or decreased. Thereby, the speed will be depending. Right, very good. Yes, sir, synchronous will be disturbed between the stator and rotor. Yes, that's what the point. Distributed. Okay, right. Very important. But still, I'm not having satisfaction. I'm not thinking that many people understood. I'm giving this topic again. Concentrate here. See, reduced speed is there here. Reduced speed is there means what is a flux cutting? I'm not talking about flux. I'm talking about flux cutting. Flux cutting is less. Flux cutting is less due to this EMF, due to this current, due to this flux. So therefore, this is the flux due to the reduced current, due to the reduced EMF, due to the reduced flux linkage. Therefore, this flux will be opposing this. But concentrate here. This flux, kind of, this is the exact terminology. This resultant flux opposes the reduction effect. This resultant flux opposes the reduction effect. Opposing the reduction means increasing or not? Increasing. Speed will be increased. Second point. Speed is more, for example. Flux will be more. EMF will be, current will be, flux will be. So therefore, this flux opposes this incremental flux, decreases, speed will be decreased. That's why always properly maintained, always properly regulatory, always properly maintained. At least now it is clear, I think. You should not say controlling torque is provided brake magnet. It is a braking torque only. Don't say controlling, it is a braking torque only. Right. Paul Varun, no, just only assumption only. Ashish, at least clear now? Ashish, at least clear after my second time explanation? Very good. Correct, Dinesh? Right. Yeah, simply. Yeah, electrical people, I don't have any problem. But IN people, only simple new topic, this one. Don't say your own words, it is a braking torque. That's it. Don't say controlling or back EMF or etc. It's just Srividya, not self-control, it is a braking torque, simply. Ashish, is clear? Okay. Right. So this is the total operation regarding energy meter and construction corresponding mathematics. And finally, sir, if I'm the manufacturer, assume that myself is the, okay, no problem. Ashish, I'll talk to you. Right. Sir, myself is a manufacturer. For example, I have designed this device. I have designed what are the thing I have taken, I designed. I'm selling to you as the company person. Do you purchase or not? In the fun way I'm asking. Do you purchase or not? Just for fun, I'm asking the question in this way. I'm the manufacturer. I designed this device. Do you purchase or not? No answer. Come on, come on. No. If you sell, I will buy, sir. See, actually, don't that much too diplomatic answer. Simply, what is my meaning of my question, is depends upon performance and accuracy. Mono correct. I told you, no, it is everything is working properly. Some problem is there. I modified with the permanent magnet and I have given the corresponding things properly. Everything is proper. That's why I'm asking, do you purchase or not? Means my question meaning is, right. Okay. My question mean, okay. I told in the fun way, you are giving too much of fun way answers. Okay, no problem. Right. Ashish, it is working here. It is working. Just now, I have spent almost 2 hours of time. It is working only. Working. Actually, meaning of my question is it completed or not? That's what I'm asking. See, this is the device working properly. Already I explained with the braking magnet and everything I explained. But you should not purchase. You should not purchase because something is missing in that. What is that something? Means, sir, so far I have checked. So far I have checked. Aishwarya, oh, very good. Standard only here. It is standard only here. Don't you believe me here? It is standard only. It is standard only. But even though it is standard, even though it is working, even though all modifications done, everything is done, still you should not purchase. Still you should not purchase. Sir, why? Sir, why? Something supply is missing. Who no? Who is this? Come on. No one will give supply here. No one will give supply. Supply from your house. No one will give supply. Kindly, come on. The point here is, sir, in this device, something is missing. What is that something? Again, for 5 to 10 minutes of time, no one should write anything. No one should write anything. The point here is, concentrate. Sir, during the load, I have tested. Suppose if the load is removed, if the load is removed, even after removing the load, if the energy meter continuously rotates, energy meter disk continuously rotates, do we purchase here? Never, never, we never purchase. So that's why, what is it here? Only we have explained, only we have taken the corresponding operation for which one here? Which one? Loading condition only. But sir, under unloading condition, what will be the problem? We need to check two conditions compulsory. No load condition as well as full load condition or loaded condition. That's why you take any machine experiment, definitely no load test will be there, loaded test will be there, otherwise full load test or short circuit test or blockwood rotor test like that will be there. That's why definitely no load test is also very, 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 very important. Means if the load is not there, then will it be working properly or not? Will it be working properly means load is not there, disk has to stop. This has to be stop. Yes, working properly. Load is not there, disk is rotating, not working properly. That's what the point. That's why under no load condition, you have to check it. Under no load condition, sir, under no load condition, IC will be 0, phi C will also be 0, phi C will also be 0. Sir, on this aluminum disc, which flux is there now? Phi P is there, phi P is there, cutting this. Anyway, permanent magnet will be there. So this phi P is small or large? Concentrate, IP, very, very small. Why? This potential coil is which one here? Highly resistive, highly inductive. Therefore, IP is very small. Sir, IP is very small, phi P is very small, permanent magnet is also small permanent magnet only. Yes, therefore, due to this, the disk is still getting the flux cutting. Therefore, disk is getting rotated. But with a small speed or with a large speed means small speed, very, very less speed, it is very slowly rotating. But even though it is very slow, come on here, even though it is very slow, Ravi Kumar, kindly leave the session. Kindly leave the session. Otherwise, don't ask the question while I'm talking. Right now, concentrate. Sir, while if you do that, I'll be missing my continuation. What is it here? Disk is rotating continuously, but slowly. That is due to which one here? What is it? Shunt magnet excitation continuously throughout the day. Simply, we can switch off the load, but can we switch on this entire value? No. This is coming from the pole service wire. We can say service wire. We cannot cut it. That's why this potential coil will be 24 hours excited. Potential coil will be 24 hours excited throughout the day. That's why due to this, even the small flux cutting, therefore disk is rotated. Is it error or non-error operation here? It is error operation. Yes or no? That's why this type of error is called as creeping error. This error is called as creeping error. Very, very, very important thing. Creeping error. Okay, sir. What is creeping error? I'm writing now. What are the thing I told you? This I'm writing now. The slow but continuous rotation of the aluminum disc is called as creeping error. Means under no load conditions, Lakshmi Kiran, just now I instructed one person to leave the session. Do you want to also leave? Right. The slow but continuous rotation of the aluminum disc is called as creeping error. Therefore, it is rotating continuously means automatically disk is rotating, spindle is rotating, gearing pinion mechanism will be working, gear will be rotated slowly, meter reading will be increased, not heavily but slowly. Even though it is slowly, even though it is changed by small value, even though it is increased by small value, definitely Meter reading will be unnecessarily increased or not. As an operator, do we accept that? No way. We need to eliminate it. Okay, but in order to eliminate that, we should know, we, sh we should know that it is due to, we should know that it is due to what? That we have to concentrate. It is due to which one? Here, I told you it is due to shunt magnet flux. That is 5 I told you. Shunt magnet flux. Of course, permanent magnet that is there, but generally we write shunt magnet flux. But not only this. One more thing here. Suppose at this point, if I'm keeping high friction based arrangement, at this point, if I'm keeping high friction based arrangement, right, the moment we switch off the load, the disk will be stopped instantly. Why? High friction is there. High friction is there means in order to move that, high force is required, but potential coil flux giving less force may not be. That's why it will be stopped. But can we place high friction concept here? Never. High friction will not be. That's why here we are going to use very low friction arrangement that is called as overcompensation for friction. What do you mean by that? Oh, compensation for friction, but technically we say overcompensation for friction means, assume that simply, sir, more number of bearings are used. For example, more number of bearings are used. What does it mean? What does it mean? Even though you connect very small load, for that load also, disk has to rotate and meter has to read. That's what the point. That's why we keep very what is it here? Smooth type of rotation, that is overcompensation for friction. That's why once you switch off the load, the disk will not be stopped instantly. Why? Smooth rotation is there, therefore it will continue. After that, shunt coil flux is coming into picture. No, it's continuously rotated. Otherwise, simple logic here. If you switch off the fan, does the fan will be stopped instantly? No. Slowly it comes to rest. Okay, here also same thing. Under no load condition, due to this bearings arrangement, or we can say overcompensation friction arrangement, it will not be stopped instantly. Therefore, it is what? It tries to continuously rotate, continuously, but it has to stop. But it is not getting stopped. Why? This flux is continuously acting on this. That is the reason why the disk is rotated, slow, but rotation continuously. This is the reason of the creeping error. So that's why I'm writing here. It is due to shunt magnetic flux and overcompensation for friction. Overcompensation for friction. Due to these two reasons, the disk is continuously rotated. Due to these two, the disk continuously rotated. Suppose if it is not there, not happened, but if it is not there, what happened here? Due to that overcompensation friction, rotate, stops. But what is there? Shunt magnetic flux will be always through the 24 hours by 365 days. It will be there. That's why this disk will be keep on getting rotated. Means this energy meter is not yet designed completely. Something is missing. That's why load test done happy. Under no load, it is rotating. How do we stop this? Means many people answered already. Here on the disk, we make holes like this. Generally, we say two, but generally holes are made. So what is the purpose of hole? Very simple. I am taking the no load condition only first. One second. No load condition only I am taking. Sir, under no load condition, right? This will be 0. Okay. Only 5C, only 5P will be there. Very small. Okay. Disk is rotating very slowly. Kindly try to analyze this. What is the concept? What is it here? Disk is rotating. That very slowly. The shunt field flux is coming. It is very slowly. Shunt field flux is coming. Therefore, as it is rotating slowly, the shunt field flux enters the holes. If the shunt field flux is entering the holes, what happened here? Effective flux cutting on the disk will be reduced. Thereby, speed will be reduced. As the speed is reduced further, again slow. Again, more flux will be flowing through the hole. Again, less flux cutting the aluminum, thereby, after half or after one revolution, etc., it will be stopped approximately. So therefore, what is it here? If the holes are there, the disc is getting stopped. If the holes are there, the disc is getting stopped. I'm coming again to explain this. Concentrate. This is the disc plate. My four fingers gap is there. No, that is hole, for example. Flux is coming. Yes or no? It is rotating slowly, very slowly. Therefore, yes, flux will be entering into the holes. Therefore, effective flux cutting on the plate will be reduced. Effective flux cutting is reduced means speed will be reduced. Speed is reduced means further slow will be there. No, as it is further slow, as it is further slow, more flux is flowing through the hole. Again, less flux is cutting the disc. Again, slow, 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 reduce. Finally, it will be stopped. But finally means not 5-10 minutes. In a few seconds, it will be stopped. But that we cannot eliminate it. Okay, right. Now, people are getting one doubt. Sir, load is placed. After placing the load, do you remove these holes? No, holes will be there. But if the holes are there, sir, loading operation, loading, Lakshmi Kiran, here. That only I'm saying, sir, load is there. Load is there. What is it here? Load operation. Under loading condition, we cannot, or we should not, or we generally, what is it? Don't remove this disc. Don't remove the holes. Same thing will be taken. But sir, holes are there means flux will be passing. Flux will be passing means automatically, what is it here? The speed will be reduced. It is drawback. No, be clear. Under the loaded condition, IC will be there. 5C will be there. Kindly concentrate. Sir, 5C is large. Why? Based on the large load current, 5C will be large, and therefore, what is it here? Correspondingly, concentrate. 1 second. Here. Right, sir. The holes will be continuously operated, but under the load condition, large flux is there. Therefore, which flux is cutting the disc now? Large amount of flux is cutting means large speed will be there based on the load. As the large speed is there, what's it here? The disc will be rotating very fastly, Sir, if the disc is rotating very fastly, do you have much flux is passing to the hole? We can say negligible flux is passing the hole. We can say flux will not pass the hole. Why? The plate is rotating with very high speed. Very high speed means the hole is there, but looking like hole is not there. Automatically, this entire fast rotation, due to that fast rotation, holes effect will be neglected. Holes effect will be not into picture. That's why the concentrate. Sir, under no load condition, holes are dominating. Thereby, these holes are stopping the disc. Okay. But under loaded condition, holes are negligible effect. Holes are having negligible effect. Therefore, the disc continues to rotate. No problem. But in order to understand this, one more practical example I'm giving. The point here is, right, and the point here is, concentrate here. Sir, suppose you take one plate, make some holes, rotate that plate very slowly. You can observe the holes clearly. Means effect of holes is dominating. Okay, next. if the same plate with same holes is rotated with large speed, then the plate is looking like there is no hole on the plate. Are you able to visualize this one? So one plate, some holes, rotate slowly. Therefore, what is it here? You can observe all the holes clearly, so that holes effect is dominating. Second one, same plate, rotate with large speed. It looks like it is a plain plate. There is no holes at all. That's why holes are there. But effect of holes is different. Effect of holes is different. Same logic. Vishnu, very good. Fan also, if it is rotating with high speed, it looks like there is no fan blade. But fan blade is there. No, that is not the simple logic. Right? That's why. Well, how can we eliminate this here? Very good. Sir, sorry, here it is eliminated by, it is eliminated by holes, holes or holes made aluminum disc, holes made aluminum disc, it will be eliminated blindly. Right. Under no load condition, that is the unwanted rotation that is produced by only one flux, only one flux. It is nothing but what is it? This flux is cutting the conductor, force is normal concept, not only one flux. It is also there, but the very, very small, no need to worry. That's why simply we can say shunt magnet flux. We say, actually speaking, what is it? Permanent magnet also to be written, but no need to write. Permanent magnet is very, 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 very small. Why? Only to adjust the speed, that is very small adjustment. No need to mention. Right. Right, very good. Vamshi, that only I am saying this is not the actual torque. This is the torque under no load condition. What is it here? 5P will be there. And one more, permanent magnet will be there. No, due to that, the rotation will be there. Due to that, rotation will be there. Jayasri, completely we cannot say, but eliminated we can say. Not completely, but writing purpose eliminated. Wherever I'm writing eliminated in my measurement, that is reduced to the minimum level. That's not the point. Right. Concentrate. So this is the total discussion regarding the entire energy meter. Right. Right. Okay. See, very good question. So sometimes we don't use any load, but minimum bill provided. No, that is called as maintenance charge. We say maintenance charge. Definitely, because even suppose you are going, all topics I'll take actually. Suppose you are going out of station, switched off the load, but you are connecting to supply or not. You are connecting to supply or not. So therefore, after coming back from your tour and all, the moment you switch on the things, the supply is to be given, means that is called as generally service charge, you can say. Okay, service charge. Right. Right. Ravi Kumar, no problem, no problem. See, if I say you leave the session, means don't think like I'm personally grudge based. I'm saying no, intentionally I'm making you alert. If I shout at you, what will I get here? Nothing. My throat will be pain. That's it. If I say that, you will be set right. That is the main point. Don't take it to heart. If you take it to heart, I will be fully formal then. I will be fully formal then. That's what the thing. Right. Bunga Tarun, do you want to have the power theft procedures? Right. See, that's what the thing. See, this is what the very deep concept, but nowadays we are not using this because the technology development, it is mechanical type, etc. Is then nowadays everything is digitalized. We are based on the world development. We need to proceed. Right. See, I'm coming again. This very, very genuine doubt for everyone. Sir, after making the holes and everything, load is placed. I'm repeating this again. Load is placed. Means this is into picture. If this is into picture, automatically disk is getting rotated with a considerable high speed. As it is rotating with considerable high speed, the flux cannot find the path through the hole. Mostly it cannot find path to the hole. Automatically all the flux will be, what is it, cutting the disk only. Then automatically speed will be proper. No need to worry. If any smallest flux is negligible, that is what commonly expected. Yes. Three phase, same operation. Three phase, same operation, but three phases will be there. Everything is same operation. But nowadays digital meters, but don't worry, digital meters are also there, but not energy. Digital voltmeter will be studied in the electronic measurements. No need to worry. Sir, in no load condition, flux due to PC is available, but eddy current due to CC is not available. Then how? torque produced. See, concentrate. That is not the actual torque. Two types of will be there. Torque under normal condition, torque under no load condition will be there. Whatever the speed is there, no, good question. Whatever the speed is there under no load condition, that is not the actual torque. Due to the small flux cutting, based on the Lorentz force equation, small force is produced. That is not the actual, what is that? Torque. That is simply unwanted torque. For that, there is no actual loss, simply directly coming into picture. Right. So speak few words about ESC measurement exam. I am covering both. Whatever the topic I have taken so far, everything is related to GATE as well as ESC, both. All concepts are important for both. Conceptual questions will be there in the ESC. Concept based numerical questions will be there in the GATE paper. That's it. Right. See, protection scheme means nowadays MCBs are there. Protection scheme means nowadays MCBs are there. If MCB is there, high current is there, that will be tripped. That will be tripped automatically. Okay. Vashishta, don't worry. Everything is, I am covering both GATE and ESC. No need to worry. No need to worry. Because by using holes, we should stop the disk rotation to 0. Definitely 0 only, but it will take little bit half a revolution. That is commonly present. The supply we are giving from our house main service line, sir. Okay, this is very common doubt for everyone. Right, concentrate. This is a practical device. So many questions will be the same. This is your street pole. 1, 2, 3, 4. Like 4 bytes will be there. This is phase. This is neutral. These two. This is your house. These two wires will be coming and given to the energy meter. These two wires, nothing but these two wires, this and this. After that, what will be there? Energy meter. After the energy meter, output side means these two, this and this, connected to the load. I told you, load means here one switchboard will be there, main switchboard will be there. From this, hall, kitchen, bedroom, etc., balcony, everything will be divided. That's why this is the energy meter. After that, main switch. After that, distribution switches will be available in your home. Under no load condition, blindly the flux is cutting the disk, torque is produced. More than that, not required, because that is not the actual torque. To have the proper rotation, that is due to what I told you, due to which one here? Overcompensation for friction also. Overcompensation for friction also. That is what the point. Okay, next, Likita. Yes, PM is less than PT. Advantage to customer, but drawback to supplier. They don't accept it. They don't accept it. Right, Vaishnavi, sir, the PM effect is less on creeping error. Yes, that's what the point. Very good question. Very good. So if you don't mind, can you tell me why we have to take aluminum holes if there are not? What happened? Come on here. So far I explained the total discussion. Creeping error only. I explained almost 15 to 20 minutes. I explained. We're asking me to explain again. That is what the main headache. If I am speaking one word, focus that only. But still, see, if this is the habit you continue in the coming discussions, power systems will be there, machines will be there, power electrons will be there. I'm feeling, what is it differently? How do you understand all those topics? Because you are keep on typing the questions. Keep on typing the questions. I'm speaking, I'm clarifying, you keep on typing. Right. So this is a total thing regarding energy meter construction, operation and all. Every point to point numerical, everything I gave you. Now let us have the doubt session. After that, numerical questions and one more topic is there. We'll continue tomorrow. No need to worry. Only what we're taking are construction and all. But people are waiting. Sir, how to mal operate? I'll give you tomorrow. No need to worry. No need to worry. I'll give you. but you cannot do nowadays, no problem. Likita, I'll tell you that in the tomorrow's class, don't worry. Yes, Muhammad Faizanuddin, yes. That's one more thing. See, tomorrow class is there. See, people are leaving, I think. Class is there tomorrow. Class is there tomorrow. Same, 5 to 9. Actually, usually Saturday break, no. But I will be taking that break in the next Tuesday or Wednesday. I'll let you know. Tomorrow class is there. So kindly be clear. Class is there, 5 to 9, as usual. Sir, session is not there. That will be created. Don't worry. Tomorrow, 5 o'clock, no time is there. They will create the session. No need to worry. Right? Okay. Now.
Sir.
Yeah.
Sir, ఒకసారి డిఫ్లెక్టింగ్ టార్క్ ఓపెన్ చేస్తారు.
డిఫ్లెక్టింగ్ టార్క్ ఈ క్వశ్చన్ అమ్మా?
ఎస్ సార్. ఇక్కడ మీరు 5P నుంచి ఐఈసి నుంచి తీసుకున్నారు కదా సార్, అక్కడ నాకు కొంచెం వైఫై స్టాక్ అయింది సార్, అందుకు ఒకసారి చెప్తారా సార్ ఎందుకు తీసుకున్నారు?
5P అండ్ ఐఈసి ఎందుకు అంటే, ఐఈసి అంటే కరెంట్ కాయిల్, 5P అంటే పొటెన్షియల్. ఎప్పుడు కూడా మనకి టార్క్ ఎలా వస్తుందంటే, ఒక కండక్టర్ కరెంట్ ఇంకొక ఫ్లక్స్ లో వేరే ఫ్లక్స్ లో ప్లేస్ చేస్తే కరెంట్ క్యారింగ్ కండక్టర్ ఈస్ ప్లేస్డ్ ఇన్ ద మ్యాగ్నెటిక్ ఫీల్డ్ ఎక్స్పీరియన్స్. అందుకని ఈ కరెంట్, ఈ ఫ్లక్స్ పి ఉంది కదా పొటెన్షియల్, ఇక్కడ కరెంట్ కాయిల్ రివర్స్ ఫ్లక్స్ తీసుకోవాలి. అది లా. వెనెవర్ ఏ కరెంట్ క్యారింగ్ కండక్టర్ ప్లేస్డ్ ఇన్ ద అదర్ మ్యాగ్నెటిక్ ఫీల్డ్, నాట్ ఇట్స్ ఓన్, ఇలా తీసుకోకూడదు. ఓన్ ఎప్పుడు కూడా మనకి టార్క్ రాదు, అందుకని ఆపోజిట్ తీసుకుంటాం.
ఓకే సార్. సార్, ఒక డౌట్ ఉంది సార్. అంటే ఇప్పుడు మనము ఖాళీగా ఉన్న ఇల్లు మనకి కరెంట్ యూజ్ చేయం కదా సార్.
అవునమ్మా.
యూజ్ చేయనప్పుడు పవర్ ఒక యూనిట్ కూడా కాలేకపోతే అప్పుడు 0 కరెంట్, 0 రేటింగ్ ఇవ్వాలి కదా సార్. అప్పుడు అంటే కరెంట్ బిల్లులో మళ్ళీ ఎందుకు వేస్తారు సార్ మినిమం కరెంట్?
అదే ఇప్పుడు మీరు ఇంట్లో యూజ్ చేయట్లేదు అయినా సరే, ఏం చెప్పాను నేను, అయినా సరే మీరు పవర్ తీసుకున్నారు పొటెన్షియల్ కాయిల్ ద్వారా. ఏమన్నాను, ఆ హోల్స్ ఉండడం వల్ల ఎలిమినేషన్ అవుతుంది అని, కానీ 100% ఎలిమినేట్ చేస్తామా? చేయం కదా, కొంచెం ఉంటుంది. దాని ద్వారా లైట్ గా రొటేషన్ ప్లస్ మీరు వాడినా వాడకపోయినా సర్వీస్ ఛార్జ్ అంటారు అనమాట. సర్వీస్ ఛార్జ్ అని వేస్తారు. అందుకని మీకు జాగ్రత్త చూడండి, 1995 ఈ మంత్ రీడింగ్ ఉంది, నెక్స్ట్ మంత్ కూడా 1995 ఉంది అనుకోండి. ఈ 1995 సేమ్ రీడింగ్ ఉంది, 1995 పాయింట్ సంథింగ్, ఓకే ఐడియల్లీ ఉంది అనుకోండి. అయినా సరే అంటే అప్రాక్సిమేట్ గా ఒక 180 రూపీస్ బిల్ వేస్తారు. ఎందుకంటే దీన్ని ఏమంటారంటే సర్వీస్ ఛార్జ్ అంటారు. మీరు యూజ్ చేసినా చేయకపోయినా ఆ డిపార్ట్మెంట్ వాళ్ళ పోల్ సర్వీస్ వైర్ కనెక్ట్ అయి ఉంది కాబట్టి మీకు డెఫినెట్ గా. నేను కట్టను అన్నాను అనుకోండి, సపోజ్ మీరు కట్టను అనుకోండి, వాళ్ళు ఏం చేస్తారంటే ఈ కనెక్షన్ ఉంది కదా మన పోల్ నుంచి వచ్చే కనెక్షన్, వాళ్ళు కట్ చేసి వెళ్ళిపోయారు అనుకోండి. మీరు టూర్ నుంచి వచ్చారు, మరి మనం సప్లై ఇద్దామంటే లేదు, మళ్ళీ వాళ్ళని కలవాలి, మళ్ళీ మరి కాల్ చేసి రమ్మనాలి, అప్పుడు మళ్ళీ మీరు అప్లై చేసుకోవాలి, మళ్ళీ ఫైన్ పడుతుంది, ఎక్స్ట్రా అమౌంట్. అందుకని 180 రూపీస్ ఛార్జ్ వేస్తారు, జనరల్ గా ఛార్జ్ వేస్తారు. కాకపోతే ఎలక్ట్రిసిటీ బిల్ లో నాట్ ఓన్లీ దిస్ ఛార్జ్, చాలా రకరకాలు ఉంటాయండి. అంటే యాక్చువల్గా ఇవన్నీ నేను ఆన్లైన్ లో చెప్పకూడదు. ఏంటంటే గవర్నమెంట్ ఇష్యూస్ అన్ని కూడా మన బిల్లు వేసేస్తాను తెలియకుండా. ఎక్కడైనా లాస్ వచ్చింది అనుకోండి, ఏదైనా కోల్డ్ లాస్ ఏదైనా వచ్చింది అనుకోండి, మళ్ళీ ₹1 పెంచేస్తారు. ఇన్ని కోట్ల ఇళ్లలో ఒక్కొక్క రూపాయి అంటే వాళ్ళకి అది వసూలు అయిపోతుంది ఆటోమేటిక్. అవన్నీ ఈ హిడెన్ ఛార్జెస్ ఉంటాయి అన్నమాట. అంతకంటే ఎక్కువ చెప్తే కుదరదు. ఇది సింపుల్ పాయింట్.
ఓకే సార్. సార్, ఇప్పుడు ఏ కనెక్షన్ లో అయినా కానీ స్టార్ గానీ డెల్టాలో కానీ న్యూట్రల్ అనేది కంపల్సరీ ఉండాలా సార్?
డెల్టాలో ఎందుకు ఉంటుందమ్మా న్యూట్రల్? డెల్టాలో ఉండదు. డెల్టా అంటేనే వితౌట్ న్యూట్రల్.
ఓకే స్టార్ లో అయినా కంపల్సరీ ఉండాలా సార్?
న్యూట్రల్ పాయింట్ ఉండాలి. అమ్మ చూడమ్మా, స్టార్ అంటేనే ఇది, ఈ కాంబినేషన్ పాయింట్ ని న్యూట్రల్ అంటారు. ఆ తర్వాత న్యూట్రల్ వైర్ ఉంటుందా లేదా అనేది మన ఇష్టం, కానీ న్యూట్రల్ పాయింట్ అయితే ఉండాలి కంపల్సరీగా. అదే స్టార్. స్టార్ అంటేనే ఇది 1, 2, 3 ఈ మూడింటిని కలిపితే వచ్చేదే న్యూట్రల్ పాయింట్. అది కామన్ ఉండాల్సిందే. అతను మీరు వైర్ తీసుకున్నది మన ఇష్టం, బట్ న్యూట్రల్ వైర్ మాత్రం కంపల్సరీ, న్యూట్రల్ పాయింట్ అయితే కంపల్సరీ.
సార్, అంటే న్యూట్రల్ అంటే గ్రౌండింగ్ కదా సార్, అంటే గ్రౌండింగ్ ఇచ్చినప్పుడే
న్యూట్రల్ అంటే ఒక నిమిషం, ఇది ఎలక్ట్రికల్ పెద్ద హెడేక్ ఇది మనకి. న్యూట్రల్ అండ్ గ్రౌండ్ రెండు సేమ్ కాదు. గ్రౌండ్ ని న్యూట్రల్ వైర్ గా యూజ్ చేసుకోవచ్చు, కానీ రెండింటికి డిఫరెన్స్ ఉంది, రెండు సేమ్ కాదు. ఇదే మెయిన్ ప్రాబ్లం. జనరల్ మనం ఏమనుకుంటామంటే, ఇప్పుడు మనకి కాలేజీలో స్ట్రీట్ లైట్స్ ఉంటాయి. కాలేజీలో మీరు వెళ్తా ఉంటుంటే స్ట్రీట్ లైట్ ఉంటుంది, వాటికి ఒకటి ఫేజ్ ఉంటుంది, ఇంకోటి వైర్ తీసుకొచ్చేసి ఎర్త్ పెట్టి ఉంటుంది, ఎర్త్ పెట్టి కనెక్ట్ చేసేస్తారు. అంటే ఎర్త్ నే న్యూట్రల్ గా యూజ్ చేసుకుంటున్నారు. అంతే తప్పితే న్యూట్రల్ వైరే ఎర్త్ అనకూడదు. ఎర్త్ ఈస్ యాక్టింగ్ యాజ్ అ న్యూట్రల్ వైర్, దట్స్ ఇట్. రెండు సేమ్ కదండి.
సార్ 3 ఫేజ్ వైర్ అనేది 4 వైర్ అంటే న్యూట్రల్ కి కనెక్ట్ చేస్తే ఏమవుతుంది? 3 ఫేజ్ వైర్‌లో చేస్తే ఏమవుతుంది సార్? అంటే
అర్థం కాలేదు.
డిఫరెన్స్ అంటే
అర్థం కాలేదు.
ఇప్పుడు న్యూట్రల్ తీసుకోకుండా కనెక్ట్ చేసినప్పుడు
అమ్మా ఒకటి
ఎలాంటి రెస్పాన్స్
అర్థమైంది,
వస్తుంది?
అర్థమైంది. సింపుల్ అమ్మా. న్యూట్రల్ వైర్ తీసుకుంటే ఏమవుతుంది, తీసుకోకపోతే ఏమవుతుంది, అదే మీ క్వశ్చన్.
అదే
సింపుల్ పాయింట్
రెస్పాన్స్
అమ్మా.
ఏమొస్తుంది?
ఇప్పుడు న్యూట్రల్ వైర్ ఎందుకు ఎప్పుడు వైర్ తీసుకుంటాము అంటే, మీకు యాక్చువల్ ట్రాన్స్మిషన్ వస్తుంది. ట్రాన్స్మిషన్ అయిపోయిన తర్వాత, డిస్ట్రిబ్యూషన్ అయిపోయిన తర్వాత మనకి పవర్ కన్జంప్షన్ ఉంటుంది కదా. అంటే ఎన్ని స్టేజ్స్ ఉంటాయి? జనరేషన్, ట్రాన్స్మిషన్, డిస్ట్రిబ్యూషన్, కన్జంప్షన్ అంటాం. ఆ కన్స్యూమర్ సైడ్ వచ్చేసరికి అయితే మన లోడ్స్ అన్ని ఏవి? సింగిల్ ఫేజ్ లోడ్స్. అయితే ఇప్పుడు ఇక్కడ మనకి ఈ వైర్ లేదనుకోండి, మన ఇంటిని కనెక్ట్ చేయొచ్చా దీనికి? లేదు. ఎందుకు? మన ఇల్లు ఏది? సింగిల్ ఫేజ్. సింగిల్ ఫేజ్ అంటే మనకి ఏముండాలి? న్యూట్రల్ వైర్ ఉండాలి. ఇక్కడ మన హౌస్ కనెక్ట్ చేస్తాం, ఇక్కడ ఇంకొకరి హౌస్, ఇక్కడ అట్లా అట్లా కనెక్ట్ చేసాం అనుకోండి. అప్పుడు ఏమవుతుంది అంటే న్యూట్రల్ వైర్ ద్వారా, అంటే సింగిల్ ఫేజ్. ఎక్కడైతే మీరు లోడ్ కనెక్ట్ చేయట్లేదు అనుకోండి, ఓన్లీ ట్రాన్స్మిషన్ మాత్రమే అనుకోండి, ఇక్కడ నుంచి ఇక్కడికి 100 కిలోమీటర్స్ ట్రాన్స్మిట్ చేసేయండి. ఇక్కడ మనకి న్యూట్రల్ వైర్ తీసుకోవడం అవసరం ఉందా? లేదు. ఎందుకు అంటే న్యూట్రల్ వైర్ తీసుకున్నాం అనుకోండి, ఈ వైర్ కాస్ట్ కూడా పెరిగిపోతుంది. అందుకని ట్రాన్స్మిషన్ చేసేటప్పుడు స్టార్ లో ఎక్కడైతే ఉందో అక్కడ నార్మల్ 3 వైర్స్ తీసుకుంటారు. ఇది ట్రాన్స్మిషన్ అండి. ఇక్కడ ఒక సబ్ స్టేషన్ ఇక్కడ రైట్ ఇలా ఉంది అనుకోండి, ఇలా ఉంది. ఇక్కడ మన హౌసెస్ వచ్చేసాయి, అంటే కన్స్యూమర్ వచ్చారు. ఇప్పుడు దీన్ని 4 వైర్ లాగా తీసుకుంటారు అనమాట. ఇప్పుడు దీన్ని ఈ వైర్ ఇటు, ఈ వైర్ అండ్ ఈ వైర్ తీసుకొని, న్యూట్రల్ వైర్ తీసుకొని ఇక్కడ, అంటే ఎక్కడైతే మీకు సింగిల్ ఫేజ్ లోడ్స్ కనెక్ట్ అవుతున్నాయో అక్కడ 4th వైర్ తీసుకుంటాం. ఎక్కడైతే సింగిల్ ఫేజ్ లోడ్స్ లేవో, 3 ఫేజ్ లోడ్స్ డైరెక్ట్ గా ఉన్నాయో, ఈ వైర్ ఇట్లా కనెక్ట్ చేస్తాము, ఇలా కనెక్ట్ చేసేస్తాం. న్యూట్రల్ అవసరం లేదు అప్పుడు మనకి. అందుకని ట్రాన్స్మిషన్ అంతా కూడా ఎక్కడ మన సింగిల్ ఫేజ్ లో కనెక్ట్ చేయం కదా, న్యూట్రల్ అవసరం లేదు. అందుకే డిస్ట్రిబ్యూషన్ కి వచ్చేసరికి 3 ఫేజ్ 4 వైర్స్ ఉంటాయి. అదే బయట చూస్తే 3 వైర్స్ ఉంటాయి. ఎందుకంటే ట్రాన్స్మిషన్ డెల్టాలో కానీ, జనరల్ డెల్టా చూసారు అలా లాంగ్ రూట్ లో వచ్చేస్తుంది అనమాట. అది పాయింట్. ఓకేనా
సార్? ఎగ్జాక్ట్ గా ఏసీ పవర్ కి డీసీ పవర్ కి డిఫరెన్స్ ఏంటిది సార్?
ఏసీ పవర్ కి డీసీ పవర్ కి అంటే ఎక్కడైతే పవర్ అనేది కాన్స్టెంట్ ఇండిపెండెంట్ ఆఫ్ టైం ఉందో డీసీ పవర్. ఏసీ పవర్ అంటే టైం టు టైం చేంజ్ అవుతా ఉంటుంది. అది డిఫరెంట్ వేవ్ ఫార్మ్స్ లో ఉంటుంది.
సార్ అట్లా అన్నప్పుడు మన ఇంట్లో చేంజ్ అవుతుందని ఎట్లా చేసుకుంటాం సార్? చేంజ్ అవ్వదు సార్. అంటే ఇప్పుడు మన ఇంట్లోకి వచ్చే పవర్ అయితే కాన్స్టెంట్ గానే ఉంటుంది అనుకుంటా కదా సార్? చేంజింగ్
అంటే ఎలా చెందుతారా? జనరేషన్ లోనే తెలుసు మనకి. జనరేట్ అయ్యే ఈఎంఎఫ్ ఆల్టర్నేటింగ్ ఇన్ నేచర్. మనకి ఏదైతే జనరేట్ అవుతుందో అది ఆల్టర్నేటింగ్. మీకు మిషన్స్ లో ఇక్కడ ఫారడేస్ లాలో వస్తుంది. మనకి ఏ మిషన్ తీసుకున్నా జనరేట్ అయ్యే ఈఎంఎఫ్ ఆల్టర్నేటింగ్ ఇన్ నేచరే. అందుకని ఏసీ నేచర్. డైరెక్ట్ డీసీ ఈఎంఎఫ్ జనరేట్ కాదు మనకి. మన జనరేట్ అవి తీసుకుంటే గనక ఏసీనే జనరేట్ అవుతుంది. దాన్ని డీసీగా కన్వర్ట్ చేసుకొని మనం వాడుకుంటాం అంతే. Right. Ashish?
Good evening, sir.
Yeah, good evening. Tell me.
Sir, can you go to the slide where the picture of energy meter?
You want figure?
Yes, sir.
Yeah.
Yes, sir. Here you said, sir, because of load, the disk is rotating.
Yeah.
Sir, how's that rotating? Sir? How deflecting torque is working here, sir?
How deflecting torque is
working, sir? Yes, sir.
Okay. Your instrument is no problem. Do you know Lorentz force equation?
Lorentz force, yes, sir. I know where the
F is equal to BIL sin theta something. Okay. Simple logic. Yeah. Yeah, this is general doubt for instruments people mostly. How it is rotating, how the torque is rotating. Simple logic here. Whatever the thing I told you in my entire earlier instruments, same thing here. See, I have taken one video also. This is permanent magnet. After that, I'll come to this. This is the aluminum cylinder coil. Okay, here flux is flowing like this, right? Here supply is given. Okay, due to this supply, current is flowing. Current carrying this box is coil.
That's okay, sir. That's okay.
Same thing here also, same thing.
So here from where we are getting current, just because of that we are getting eddy currents here because of that pressure coil current. We are getting eddy current.
That's what. Yeah. Okay. You want conceptually? Okay, no problem. Yeah. Got it.
How it's getting current, sir?
Simple logic here. Eddy current concept is clear, right?
Yes, sir. Because of that flux is linkage to aluminum disc. That's why eddy currents are produced generating.
Yes, I got it. Okay, no problem. Come here. Simple logic, sir. Here, because of this IC, 5C will be there, cutting this eddy EMF, 5P cutting eddy EMF due to this current. Sir, the moment current is produced, what we can say? Current carrying conductor placed in the magnetic field of shunt as well as series, anything. So therefore, current carrying conductor placed in the magnetic field experiences a mechanical. That's why I told you Lorentz force principle. See, after production of current, mathematically I told you this is linking, etc. Current carrying conductor means aluminum disc placed in the magnetic field. Current carrying conductor placed in the magnetic field, automatically current carrying conductor placed in the magnetic field, it experiences a mechanical force. Therefore, it is getting rotated. Simple logic.
So, sir, the here the magnetic field present is because of permanent magnet, right, sir? That working magnet, because of its rotating. Is it so?
Which one?
Sir, because of pressure coil and current coil, the eddy currents are generating in the coil, right,
Yes.
sir?
Okay.
And then where is braking magnet? Permanent magnet is there. Then another field is there. Because of this, is it rotating?
See, these two are giving the rotation. This is added to maintain these two flux contribution here. That's why, because of this also rotating, we can say, but major role is this only. This is only to adjust the flux only. Of course, braking magnet also providing the torque, okay, but this braking magnet flux is very small. That's why we should not say due to the braking torque also it is rotating. We should not say main operation due to this only. But any unwanted operation or more or less speed is there, that will be modified this. No, that's why we say braking is only for braking purposes. Generally rotation is this one only. But according to your point, it is also coming here. Then only proper operation will be there. But kindly don't say because of braking magnet also it is rotating. No, you should say because of braking magnet the disc maintained at proper speed. You should. That's it. That is better statement.
Okay, sir. So can you explain the working of that blue part?
Come on, Ashish.
That's blue part, sir.
Huh?
That
not
blue,
little bit louder here.
So the blue part, which is just below the pressure coil.
This one blue. That's what it is. Copper shading band means this is the potential coil. This is the potential coil and copper shading band or coil like this. So combination is highly inductive. This is added for high inductance purpose. Thereby, I told error. No, this one delta is made near to 92. No, that is why this copper shading band is very highly inductive part. Thereby, this entire shunt magnet structure is becoming delta equal almost 90. Error will be less. Copper shading band or coil actually like this will be there, but showing purpose and showing separately.
So the maximum flux can link to that aluminum disc, right?
Yes.
Okay, sir. Thank you, sir. Can you explain one more time the torque equations you gave here? The torque equations, sir. Yes, sir. This
total should I explain again?
No, sir. Back. No, not the phasor diagram. Yes, sir. Just simply explain this.
Yeah. Okay, no problem. Very simple. I think generally major people, especially instrumentation people, I'm expecting this doubt will be there. Very simple. Yeah. Current is there. Current is flowing to the coil, potential flux will be there. Flux
sir.
is cutting the disc, EMF will be induced. Due to EMF, current will be there. Same thing. Then the current carrying conductor placed in the magnetic field. But here, sir, why not? This means this is current carrying conductor not placed in this field. Due to this only it is coming. So that's why current carrying conductor placed in the magnetic field. Current carrying conductor placed in the magnetic field. It experiences a mechanical force. Therefore, force is because of phi P and IEC, phi C and IEP over. Then equation.
Okay, sir. Now I got it. Now the maze is clear.
Very good.
So because of the field is there, sir, can I just? I'm just saying is, I'm just saying a statement.
Yeah.
Due to pressure coil, there is magnetic field, flux is changing, and there is also magnetic field due to current coil. And because of pressure coil, eddy current is there. Now eddy current is there. Now it's opposing. Now it's it's attracting the torque is there because of current coil.
Yeah.
Is it so? Is it right?
Yes, but actual statement is because of potential coil current, potential flux will be there. Potential coil flux links the aluminum disc, eddy EMF, eddy current will be produced. Now this aluminum disc becomes current carrying conductor placed in the magnetic field of current coil
Current
flux.
coil. Yes.
Yes.
That's okay, sir. Thank you, sir.
Right.
Sir.
Yeah.
Good evening, sir.
Yeah, good evening, good evening. Tell me.
Sir, first thing is, sir, in creeping error, sir, please open that image, sir.
Yeah.
Sir, in this, sir,
Yeah.
on no load, sir, IC equals to 0 na, sir. So how we are, for IC is equal to 0 means we don't get phi C and eddy current.
Yeah, one second, Mubin, I got it. Sir, TD1 is phi P and IEC.
Yeah, the same.
TD2, yeah, phi C and IEP. Sir, IC is not there. This is not. How do you get the force? Very good. You're missing small logic here. Here already, the moment the load is removed, automatically this disc has to stop, strictly speaking. But
Yes.
due to the corresponding overcompensation for friction, what is happening here? It is continues to rotate. Okay. After that, this single flux is cutting the corresponding conductor, So what is that happening now?
EMF
Due to this flux, current will be there, flux will be there. No, due to this flux, some current will be there. No, current carrying conductor placed in the magnetic field. This is the single conductor notation. You are missing. Two fluxes are there. One to one we can take, but here only one flux is also there. What is it here? Current carrying conductor. How this current? This magnetic flux. Therefore, current carrying conductor placed in this magnetic field. Why we are taking like this means major portion is not there. Automatically, this is smoothly rotating. This flux will be aiding that speed. It will be continuously but slowly rotating. This is not the actual torque, but it's a double field revolving theory torque. Normal.
Sir, it means the conclusion is current is induced in the disc, but the magnetic field is not because of the pressure coil and current coil. It is because of braking magnet.
Yeah.
Right, sir? Yeah, sir. That's clear, sir. Sir, one more thing, sir.
Yeah.
Sir, braking magnet torque developed is constant, na, sir, independent of load?
Yeah.
For any type of
No. Yeah, actually, what they do, they will keep some X load. They will check it. They will keep Y load. They will check it. So universally, it will be constant. That's why in our home, some error will be there. No. Yes, common.
Okay. Yeah, that's clear. One more, sir. Copper shading bands means we connect a high inductive coil in series with pressure coil, sir,
Yes.
or anything different?
Correct. No. That one.
Sir, it means directly we can use high inductive coil as pressure coil, na, sir. Then extra.
Actually, normal potential coil means highly resistive concept is there. No?
Yes.
That's what we are separately using that.
Okay.
That's it.
Yeah, got
You
it.
see, even though so okay, as you said, highly inductive coil is used, not sufficient. Again, I need to add more.
Sir, sorry to interrupt.
Yeah.
Sir, in EMMC, that concepts are high resistive, but here you just now said that it should be highly inductive, na, sir. So,
No, you're missing small thing. Highly resistance already there. You missed one thing. See, potential.
many turns, PC many turns, thin wire. Yeah, sir.
See, high resistance is there, low inductance is there for this portion.
Okay.
Normally, I am adding extra resistance with copper shading band.
Extra inductance.
Sorry, extra inductance. Okay, I'll clarify one more way. Good question, but concentrate here. Suppose I want to get not this much, but 100 Henry, for example. I'm taking one coil, more number of turns, thin wire. Still, practicality, designing wise, structure wise, limitation will be there. No?
Yes.
Assume that 99 Henry is there, for example.
Okay.
Still, something is less, no?
Yes.
That's why something is. That's why whatever the coil is giving inductance, if it is not sufficient, we can go for by adding extra. That's it.
Okay. Sir,
Okay.
yes, sir, it's clear. Sir, in EMMC wattmeter, sir, if the load is unbalanced three phase unbalanced load, the number of wattmeters is 3, na, sir?
Which connection? Star or delta?
Any of the above, sir. Any of two.
One
Either
second.
star or delta, system is unbalanced.
System is unbalanced. Yeah, system is unbalanced means, yeah. But 4 wire or 3 wire?
Sir, in 4 wire means I can easily say we need 3, but in 3 wire, how?
2 only.
2 are enough. By 2 wattmeter method, we can measure unbalanced power also.
Definitely.
Unbalanced also we can measure by 2 wattmeter.
We have done one question yesterday. One like this, we have taken one. This is current coil, some resistance. Here potential coil, 100 ohm, and one box I have taken now.
Yes.
This source is balanced, but load 100 ohms is there. 100 ohms is there. Here potential coil means highly resistant, unbalanced load.
Yeah. Okay, so 2 wattmeter method.
Okay.
Yeah.
Yeah.
Sir, I did not raise my hand.
Hello?
I did not raise my hand.
Okay, right. Actually, it is showing. Okay, right. Very good.
When you asked the question, I raised.
Okay. Kindly. Right. Few people are like that only. Now raise your hand. Yeah.
Sir?
Yeah. Again,
sir,
tell me.
Yeah, sir. That didn't complete it yet. Sir, for over friction compensation, we've discussed, sir. But less friction means we are not compensating more, na, sir?
No, actually, no, not that. We are providing the less friction means we are compensating the friction. But that's not meaning. That too, suppose 5 bearings are to be placed here, for example, but we keep some 6-7 bearings. That is called as not only compensating the friction, overcompensating means we are doing some overaction. We say no in that way. Overcompensation friction means the friction is up to the minimum level we are keeping, very, very lowest level.
Okay.
That is what the meaning.
Okay. Sir, this one of the term is related to this concept, lag adjustment coil.
I'll tell you.
That's
tomorrow topic is, I'll tell you.
Okay, thank you, sir.
I'll note, I'll give you.
Yeah,
right.
thank you. Done, sir. Thank you very much.
Right. I'm asking you to unmute. Kindly unmute.
Sir, good evening, sir.
Yeah.
Sir, I have a doubt in yesterday last problem, sir. The Vetter diagram for wattmeter said that IB should interface with VY. I did not get that point, sir.
Today, this one?
No, sir. Yesterday, sir. Yesterday, last problem, sir.
Yesterday last problem. Yeah, tell me what is the doubt?
Sir, in wattmeter 3, it has sir, VBY is lagging with IB, sir, 60 degree. But sir, voltage VBY, sir, lags 60 degree, sir, IB.
Yeah.
You have said that you are explaining that IB is in phase with VYN. Sir,
Did I say that? Did I say that? Kindly go and watch the video. Did I say that?
So that I did not get that point, sir.
That's fine. That's fine. Have you watched the recorded video?
No, sir. I have done that.
Then you have to watch, no? Then you have to watch, no? If you would have watched today morning or etc., that would have been clear. See, I don't have any problem in explaining, but I don't understand you people, not you, Anil, but many people. The doubt is there. After the class, recorded video is there, notes is there, following. Then we should ask the faculty. That is a minimum thing. Not you, Anil. I don't mind. Generally, people are like that. Other faculty also same thing. The recorded video are providing for which purpose? Anil, don't mind. I'm saying this, right? See, you missed something. This is VYN. Sorry, VRN. VYN. This is VBN. Okay. So that this is the which one? Phi equal to 60 degrees. No, IB lags VBN by 60. Therefore, so 60 means where should it go? This is 120, right? Yes or no? So 60 means exactly here. What is that? IB. So this angle is 60. I told you. After that, sir, VYN is to be reversed. How do you reverse? On the same line only. It is coming. I told you also. You will get the doubt here. Listen carefully. I told you. I did not say IB in phase. No. IB lags the VBN by 60. And VYN is reversed. Unknowingly, due to this 60 degrees lagging, we are getting both in same phase. So what? Nothing.
Sir, no, I got it, sir. No, I got it.
Right? Any doubt still?
No, sir. Thank you, sir. No, I got it.
Yeah.
Hello, sir.
Yeah.
Yesterday, the delta connection, current coil and pressure coil, some 3-phase balance.
Now, what's your doubt in that?
Answer is 600. I am trying to the phasor diagram.
Voice is not clear.
In this sum, I try to phasor diagram. I am trying to in this sum phasor time way, sir. How to calculate the angle cos phi? How to calculate in this
That's
model?
why for everything phasor diagram is not suitable. One thing in the delta connected circuit, already they have given RYB sequence, and that to which one here balanced one.
Yes, sir.
What question you are asking?
In this same, I am calculate the vector sum modeling, sir.
Why? Why you want to calculate vector by vector?
Try for that.
Right? Did you get it? I'm asking, did you get it? Who is this?
Not, sir.
Ayyappan, yeah.
Not good.
Okay, did you send my number? You send it to my number?
Okay, sir. Okay.
Yeah, you send it, I'll tell you. No problem. That is extra method. No, I'll tell you.
Okay. Okay.
Hello, sir.
Yeah.
Sir, you said one question, sir. When AC supply of 8 sin omega t, the MI instrument ఇచ్చినప్పుడు అది MI instrument అనేది IRMS వాల్యూని రీడ్ చేస్తుంది కదా సార్ 8/√2 అనేది. కానీ డిఫ్లెక్టింగ్ టార్క్ అనేది మనకి ఈక్వేషన్ వస్తుంది కదా సార్, డిఫ్లెక్టింగ్ టార్క్ ఇస్ డైరెక్ట్లీ ప్రపోర్షన్ టు I² అని. అప్పుడు I² RMS అంటే ఇక్కడ మనం 8/√2 హోల్ స్క్వేర్ అని అట్లా తీసుకోకూడదు సార్.
Deflecting torque is proportional to I². కానీ మనకు చూపించేది ఏంటండి, ఇక్కడ 0 ఉంది, 4 ఉంది, అవునా? ఇక్కడ మీరు 4 ఇచ్చారు, 4 చూపిస్తుందా? 4 చూపిస్తుంది ఏంటి? టార్క్ ప్రపోర్షనల్ టు I², కానీ మూమెంట్ అనేది దీనికి సంబంధించింది. అది పాయింట్.
ఒకసారి మళ్ళీ చెప్పండి.
టార్క్ అనేది ప్రపోర్షనల్ టు I², కానీ ప్రొడ్యూస్ అయ్యి అంటే డిఫ్లెక్షన్ ఏదైతే ఉందో ఆ మూమెంట్ అంతా వచ్చేసి 4K చూపిస్తుంది. అంటే స్కేల్ ని ఆ రకంగా క్యాలిబ్రేట్ చేస్తారు. అంటే మీరు ఏమనుకుంటున్నారు ఐ స్క్వేర్ కాబట్టి 16 చూపించాలి కదా, అంటే మనం 4 వేస్తే 16 చూపిస్తుంది, కుదరదు కదా.
అవును సార్.
అందుకని స్కేల్ ఆ రకంగా క్యాలిబ్రేట్ చేస్తారు, అది పాయింట్.
ఓకే సార్, డౌట్ వచ్చింది.
ఓకే పర్లేదు.
Hello, sir.
Yeah.
Sir, I have one general doubt, sir. The induced EMF, eddy current, how lagging with that respective eddy EMF, sir?
See, aluminum disc, with this aluminum disc, right?
Okay, sir.
On the aluminum disc, EMF is induced and current will be produced. The moment the flux is already cutting here, the moment the flux is cutting a conducting material, it will be which one? Inductive function. Flux will be there. Magnetic system. Inductive means RL combination. Aluminum metal. How do you draw aluminum metal? Suppose copper coil is there. If you want to draw in the circuit point of, how do you draw? REL, right?
Yes, sir.
Same way, aluminum metal also nature wise, how do you draw? R and L only. RL means inductive, so therefore current will be inductive. That's why magnetic system related coil or plate or disc etc. inductive nature only. Once the flux is cut by the aluminum disc conductor, it acts as the magnetic phenomena, therefore automatically inductive nature. That's it.
Okay, sir. I'm confusing with that iron frame, sir.
Is it clear now?
Yes, sir. No, please.
Right.
Sir, good evening.
Yeah. Hello, Ravi Kumar. Yeah, tell me.
Yeah, good evening, sir.
Huh?
Sir, general doubt, sir.
Yeah.
Sir, normal గా ఇప్పుడు ఇంట్లో ఎనర్జీ మీటర్ ఉంటుంది సార్, అది ఒక్కొక్కసారి మంత్లీ అంటే కిలోవాట్ యూనిట్స్ అనేది బాగా ఎక్కువ వస్తుంది కదా సార్, అది మీటర్ ఫాల్టా లేకపోతే సమ్ అదర్ ఫాల్ట్?
లేదు, లోడ్ కన్సంప్షన్ బట్ మీటర్ ఫాల్ట్ ఏమి ఉండదు. అంటే మీరు యూనిట్స్ ఎక్కువ వస్తుంది అంటారా, బిల్ ఎక్కువ వస్తుంది అంటున్నారా?
అంటే యూనిట్ బిల్ ఎక్కువ వస్తుంది సార్.
అది సేమ్ థింగ్. బిల్ ఎందుకు ఎక్కువ వస్తుంది అంటే ఈ మధ్య డిపార్ట్మెంట్ వాళ్ళు అంటే కొన్ని మంత్స్ కి డిఫాల్ట్ గా తీసేసుకుంటారు అనమాట, టారిఫ్ అనౌట్ చేంజ్ చేసి అట్లా ఇస్తాం. బట్ రీడింగ్ పరంగా మీటర్ ఫాల్ట్ అయితే ఏముంటదండి, టారిఫ్ చేంజ్ అయింది జనరల్ గా.
యాక్చువల్గా ఇప్పుడు మా ఇంట్లో జనరల్ గా మా హౌస్ తీసుకుంటే ఒక 3 months కి ఫస్ట్ 1500 వచ్చింది నార్మల్ గా. అంటే యూసేజ్ అదే యూసేజ్ అండి. అంటే బిఫోర్ 3 months 700 అలా వచ్చేది. అంటే ఆఫ్టర్ దట్ అది బాగా ఇంక్రీజ్ అయింది. అది ఫాల్ట్, అది ఇంట్లో మీటర్
అంటే లేదు అదేంటి సింపుల్ గా. అంటే మీకు పాయింట్ ఏంటంటే సపోజ్ మీరు అంటే చిన్న అంటే ఎగ్జాంపుల్ చెప్తాను, నాట్ ఎగ్జాక్ట్ ది. 0 to 100 కనుక చేశారనుకోండి, మీరు కన్స్యూమ్ చేశారనుకోండి, ఒక యూనిట్ కి 3 rupees ఉంది అనుకోండి సపోజ్. అంటే మీకు 300 rupees అనుకోండి ఫర్ ఎగ్జాంపుల్. కాకపోతే ఏమైతే తెలుసు, 0 to 150 తీసుకుంటే అప్పుడు ఏమవుతుందంటే 0 to 100 ఒకటి, 100 దాటింది కాబట్టి 50కి 4 or 5 rupees వేస్తారనమాట. అంటే అది అందువల్ల అంటే మనకి ఒక్క రీడింగ్ సపోజ్ 0 to 101 అయినా సరే ఈ ఒక్క రీడింగ్ ఆ విధంగా మనకి ఎక్కువ అయ్యేసరికి డబుల్ రేట్ వచ్చేస్తుంది అనమాట. అదొక రీజన్ ఏ ఉంటుంది. ఇంకోటి ఏంటంటే జనరల్ గా ఇప్పుడు మా ఇంట్లో కూడా సేమ్ ప్రాబ్లం. ఏప్రిల్, మే, జూన్ ఆ మంత్ లో ఆటోమేటిక్ గా 1500, 600, 2000 వచ్చేస్తుంది. మీనింగ్ ఏంటి అంటే డిఫాల్ట్ గా ఒకసారి మొన్నటి వరకు లాక్డౌన్ వల్ల లాస్ట్ టైం కరెంట్ ఎలక్ట్రిసిటీ బిల్ వాళ్ళు రాలేదు బిల్లింగ్ కి. అప్పుడు ఆటోమేటిక్ గా లాస్ట్ ఇయర్ ఎంత ఉంది బిల్ దాని ప్రకారం వేస్తారు అనమాట. అట్లా అంతే తప్పితే ఫాల్ట్ ఏం కాదండి. జనరల్ గా ఫాల్ట్ ఏం ఉండదు, జనరల్ గా అయితే ఉండదు.
ఇంకొకటి చిన్న డౌట్ సార్, అది ఇప్పుడు వాట్ మీటర్ కి మనం నార్మల్ గా మల్టిప్లికేషన్ ఫ్యాక్టర్ ఉంటుంది కదా సార్, అది ఇప్పుడు అది ఇన్స్ట్రుమెంట్ మరి డైరెక్ట్ గా డైరెక్ట్ గా ఇండికేట్ చేయట్లేదు సార్.
అర్థమైంది. ఏంటంటే అమ్మా ఇవాళ అంటే మామూలుగా ఏం చేస్తున్నాం మనం, ఈ డివైస్ లో 0 to 600 watts ఉంది, 0 to 1200. అంటే ఒకటే డివైస్ ద్వారా 2 వాల్యూస్ వచ్చినా మనకి కాస్ట్ తగ్గిపోతుంది. ఒక స్టూడెంట్ అడిగాడు 2-3 days బ్యాక్, ఏంటంటే ఒకటే డివైస్ లో అయితే ఇప్పుడు 600 watts మనం రీడింగ్ తీసుకోవాలి అంటే పాయింట్ లో చూపిస్తుందండి. ఇక్కడేమో 300 ఉంటుంది, ఇక్కడేమో 600 ఉంటుంది. అరే 600, 300 ఇట్లా తెలియాలంటే మనకి ఇక్కడ 0 ఇది న్యూట్రల్ అనుకోండి, ఇది వోల్టేజ్ 150 volt అంటారు, 300 volt అంటారు. ఓకే, మనం ఎక్కడ యూజ్ చేస్తాం అది ప్లస్ దాని పైన ఇన్స్ట్రుమెంట్ పైన ఒక 4 టెర్మినల్స్ ఉంటాయి ఇలా C1 C2 P1 P2
ఇది తెలుసు సార్, ల్యాబ్ లో చేశాను.
అది ఆ కనెక్షన్ బేస్ అంటే ఒకటే డివైస్ లో 2 వాల్యూస్ రావాలి కాబట్టి ఇంత అరేంజ్మెంట్ ఉందన్నమాట. అంతే సింపుల్ లాజిక్.
ఉంటే డౌట్ అది కాదు సార్, అది జస్ట్ అది అబ్సల్యూట్ ఇన్స్ట్రుమెంట్ కి, అంటే ఇప్పుడు అబ్సల్యూట్ ఇన్స్ట్రుమెంట్ అంటే డైరెక్ట్ గా చూపేది కదా సార్ వాల్యూ. మరి ఈ ఇన్స్ట్రుమెంట్ ని మనం ఇండికేటింగ్ ఇన్స్ట్రుమెంట్.
వెరీ గుడ్, అదే చెప్తాను. ఇక్కడ 2-3 రీడింగ్స్ కావాలి కాబట్టి ఇదంతా. ఇది అది కాకుండా 0 to 100 watts తీసుకున్నాం అనుకోండి, ఇవన్నీ సెటప్ ఉండదు మనకి. అందుకే ఇక్కడ మనం మల్టిప్లై చేసేది కాన్స్టెంట్ కాదు, మల్టిప్లైయింగ్ ఫ్యాక్టర్ అంటాం ఇక్కడ. ఇప్పుడు అక్కడ ఏంటి
కాన్స్టెంట్
అంటే ఏంటి, అది సింగిల్ రీడింగ్ దే, ఇది సింగిల్ రీడింగ్ దే కానీ కాన్స్టెంట్ ఉంటుంది. బట్ ఇక్కడ 2-3 రీడింగ్ రావడానికి మనకి ఇవన్నీ మల్టిప్లైయింగ్ ఫ్యాక్టర్స్ అన్నమాట.
ఓకే సార్, ఇప్పుడు అర్థమైంది.
రైట్,
థ్యాంక్ యూ సార్. థ్యాంక్ యూ.
రైట్, వెరీ గుడ్.
Good evening, sir.
Yeah, good evening. Hello.
Sir, yesterday you told that here the hello.
Yeah, tell me.
Am I audible, sir?
Yeah, tell me.
Sir, yesterday you told that the losses are neglected in the measurements.
Losses are neglected in the measurements.
Hello.
For which one I told you?
Yes, sir. Sir, I asked sir whether the losses are considered, the line losses are considered here or not. I
Line
asked
losses
sir. You have told machine.
Machine, yeah. See, while you are measuring, suppose this machine is there, right? This is a machine. You are connecting some meters, yes. Okay? Meter. During the experiment, whatever the heat loss are there, temperature loss are there, magnetic etc., that we cannot consider, isn't it? But due to this, whatever the effect are there, based on that values will be there. No, we take only this one. We take only this one. That's why I told you in sir, the measurement. Tell me.
We are using wires and conductors in the machine, no, sir.
Yeah.
They will have some resistance and they will have voltage drop. Definitely. And the supply voltage will not reach to the load.
Definitely.
Then we are connecting, you have said that the wattmeter will read the load consumed power. But the power is not reaching exactly, no, sir. But that's here with respective problems, sir, we are considering the supply voltage in the calculation of wattmeter. Then yeah, I'm just confused. It is the wattmeter, then for the calculations the wattmeter is showing the true value. Am I right,
very simple,
sir?
Yeah, very simple. Numerically the corresponding value wire resistance must be neglected and can be taken. But if the same thing is given in the laboratory, suppose here 400 volt supply is there, okay, and if you're taking and here some load is etc., across this if you measure 400 will not be there. That's why in the laboratory what is unknown means this is unknown, you're missing small thing, this is unknown. If the wattmeter is showing 400, suppose 399 for example, what you say, okay, supply voltage is 399 volt, you say that is what the point. In the numerical question this will be given, right? Directly we can take it, but in the experiment analysis this will be known, this will be not known, this will be measured. That's why it will be taken over here. In the entire experiment mathematical analysis, the drop voltage will be neglected. Yeah.
But in reality, drop voltage will be high, no, sir, in the machines.
In the reality?
Or machine drop will be very high, no, sir, due to resistance and inductances.
Yeah.
Why we are not considering that?
See, again I'm missing something here. This is machine here. In the machine drop will be there. This is the machine input. This is the machine output. Okay. You are not connecting the meters in the machine. You are connecting the meters output side. You are connecting the meters input side. This reading minus this reading only loss.
Okay.
See, we are not connecting the meters in the machine. Got it?
Okay.
Got it?
Okay, sir. I got it.
Yeah.
Sir, under small basic basic question.
Yeah.
Sir, you according to this energy meter, whenever the disk is placed between the magnetic field, you have told the current carrying conductor is placed in the magnetic field, it will experience force. But before that, when starting of the energy meter, the disk will be without current, sir. Like it's just a conductor.
Yes.
Then how if a normal conductor is placed between the magnetic field, then is it experience a force? Does it experiences a force?
Definitely.
So whenever normal conductor or either current carrying conductor placed in the magnetic field, they will both experience.
You are saying normal conductor.
Normal conductor means like normal disk. Is placed in the magnetic field without any current. Then it will induce an EMF in the conductor. Thereby, for EMF, it will be converted to the current, and then experiences a flux which reacts with the main flux. Main magnetic.
Yeah.
It will experience a magnetic force, sir.
Yeah, magnetic force.
Okay. When we are directly placing a current carrying conductor, directly
mechanical
from starting.
Mechanical force due to the magnetic flux linking, we say. Mechanical force, we say.
So in both the cases, it will experience force.
See, one small thing. Yeah, in that so many conflicts are there. One current carrying conductor is there. Suppose, okay, one magnet is there. Okay, let me take one magnet is there. North and south. Okay. See, this flux will be flowing like this, etc. Yes, cutting. Conductor cuts the flux, which will be induced. EMF will be induced. Clear? Due to this EMF, if the path is being closed, current will be flowing.
Current will be flowing.
Okay. Now, current carrying conductor placed in the magnetic field experiences mechanical force if you provide the movement. If it is a fixed one, no movement. Are you getting a point or not?
Okay.
That's why. Yeah, one more thing is, sir, how much time will take me? Not much time. Flux is cut, EMF will be fractions, current will be and rotated. That is whatever machine's topic. That is whatever DC motor, etc. No, same thing.
Okay. I got it, sir. Thank you so much, sir.
Right. Welcome.
Sir. సార్ ఇంతకు ముందు ఒక అబ్బాయి అడిగారు కదా సార్, అంటే ఇట్లా హోమ్ లో ఇట్లా మీటర్ ఎక్కువ వస్తుంది అది అని. మీరు ఒక 100 యూనిట్ అంటే 100 వస్తే 101 కి వచ్చేసరికి మీకు ఎంత అయినా కానీ అంటే 3 రూపీస్ ఉన్నది 5 రూపీస్ కి అవుతుంది అని అట్లా చెప్పారు కదా సార్. ఒకసారి ఇంక్రీజ్ అయినాక మళ్ళీ 100 కన్నా డిక్రీజ్ అయినప్పుడు అప్పుడు రేటింగ్ చేంజ్ అవుతుందా సార్?
100 కంటే డిక్రీజ్ ఎట్లా అవుతుందమ్మా? అర్థం కాలేదు.
అంటే ఇప్పుడు యూజ్ చేస్తున్నందుకు ఇంక్రీజ్ అయింది కదా సార్.
అవును.
ఇప్పుడు యూజ్ చేయకపోతే డిక్రీజ్ అవుతుంది కదా సార్.
ఎట్లా అవుతుంది? యూజ్ చేయకపోతే అక్కడే ఉంటది కదా, ఎందుకు తగ్గిపోతుందమ్మా? అరే కమాన్.
అంటే మినిమైజ్ కాదా సార్?
లేదు. అయితే ఒక పాయింట్ ఇప్పుడు డిస్క్ ఇలా ఉందండి, రొటేట్ అవుతా ఉంది. రొటేట్ అవుతా ఉన్నప్పుడు ఏంటి పాయింట్? మీటర్ రీడింగ్ ఫస్ట్ న్యూ హౌస్ అనుకోండి 00 ఉంది. ఒక 1 month తర్వాత 100 వచ్చింది, రైట్? ఆ తర్వాత మనము ఒక 1 month టూర్ వెళ్ళాము, అయితే వచ్చే 0 అవుతుంది, అవ్వదు, 100 ఉంటుంది.
మీటర్ చేంజ్ అవ్వదు.
ఆ 100 నుంచి సపోజ్ ఇది మే మంత్ అనుకోండి, రైట్? నెక్స్ట్ జూన్ మంత్ అనుకోండి, పాడుతూ ఉన్నారు, అప్పుడు ఏమవుతుంది? 122, 155, 200 అలా అవుతుంది అన్నమాట. ఓకేనా?
ఓకే. అయితే డిగ్రీస్ అయితే అవ్వదు సార్, అంటే
అవ్వదు. మళ్ళీ ఇంకో డౌట్ కూడా మీకు దీని ద్వారా రావచ్చు సార్. ఇప్పుడు మే మంత్ జూన్ మంత్ అయ్యేసరికి 220 ఉంది సార్ అంటే మీరు 220కి బిల్ పే చేయరండి. మే మంత్ అయిపోయేటప్పటికి 100 ఉంది కదా, ఇది జూన్ మంత్ బిల్ కదా, రెండింటికి డిఫరెన్స్ ఎంత అంటే జూన్ లో కన్జ్యూమ్ చేసింది 120కి బిల్ వేస్తారు. అర్థమైందా? మళ్ళీ చెప్పాలా?
ఓకే, అంటే డిఫరెన్స్ చేస్తారంటున్నారు.
ఇప్పుడు సింపుల్ అమ్మా, ఈ మంత్ తీసుకోండి, న్యూ మంత్ తీసుకోండి, జూన్ ఎండింగ్ కల్లా మీటర్ రీడింగ్ 125 వచ్చింది అనుకోండి, జూన్ మంత్ బిల్ ఎంత అండి మీది? 125 యూనిట్స్ ఇంటూ సమ్ రూపీస్ పే చేస్తారు. నేను కంటిన్యూ చేస్తున్నాను, ఇదంతా వచ్చేసి ఒక 425 అయింది అనుకోండి. ఈ 425 వేరు. అప్పుడు ఏం చేస్తారంటే ప్రజెంట్ రీడింగ్ వచ్చేసి 425, ప్రీవియస్ రీడింగ్ వచ్చేసి 125. సో నంబర్ ఆఫ్ యూనిట్స్ కన్స్యూమ్ 300 ఇంటూ సమ్ రూపీస్, దానికి బిల్ వేస్తారు. మళ్ళీ నెక్స్ట్ ఏమవుతుంది, ఈ 425 నుంచి సపోజ్ ఒక 750 అయింది అనుకోండి, అప్పుడు ఏంటి, ప్రజెంట్ 750, ప్రీవియస్ వచ్చేసి 425, ఈ డిఫరెన్స్ కి బిల్ వేస్తారు. అది అంటే మీకు జీరో తగ్గే ఛాన్సే లేదండి. కానీ ఎప్పుడు తగ్గుతుంది అంటే ఇంకొకటి, అది మీకు ఏం చెప్తాను, నెట్ మీటరింగ్ టెక్నిక్ అని ఇప్పుడు వచ్చిందన్నమాట. సోలార్ ప్లాంట్ కనుక మనకి ఉంటే, అప్పుడు ఉంటుంది. అది ఏంటో చెప్తాను నేను సెపరేట్ గా.
ఓకే
హలో సార్.
యా
సార్ గుడ్ ఈవినింగ్ సార్. ఆ రోజు అడిగాను కదా సార్, మనకి ఎంసీ షార్ట్ చేస్తే, ఎల్సీ షార్ట్ చేస్తే, ఎంసీ షార్ట్ చేస్తే అది యూపీఎఫ్ కి వాడాలి, యూపీఎఫ్ లోడ్స్ కి, ఎల్సీ షార్ట్ చేస్తే ఎల్పిఎఫ్ లోడ్స్ వాడాలని. సార్ మనకి అలాగ మనం ఎక్స్టర్నల్ గా షార్ట్ చేసుకోవచ్చు కదా సార్. మరి అలాంటప్పుడు మనకి ల్యాబ్ లో 2 వాట్ మీటర్స్ ఎందుకు ఉంటాయని అడిగాను కదా సార్. యూపీఎఫ్ వాట్ మీటర్, ఎల్పిఎఫ్ వాట్ మీటర్ అని సెపరేట్ గా. అంటే మనం ఒక వాట్ మీటర్ నే రెండింటిగా వాడుకోవచ్చు కదా.
వాడుకోవచ్చు, కాకపోతే ఇది ఎంసీ, గుడ్ క్వశ్చన్. ఎంసీ షార్ట్ ని మనం నార్మల్ గా యూజ్ చేస్తే, అంటే లో పవర్ యూజ్ చేస్తే వస్తుంది, కానీ లో పవర్ ఫ్యాక్టర్ కి తగ్గట్టుగా సెపరేట్ డిజైన్ చేసి, అంటే లో పవర్ ఫ్యాక్టర్ మీటర్ లో ఇప్పుడు ఎంసీ అంటే మీన్ నార్మల్ యూపీఎఫ్ వాట్ మీటర్ ని ఎల్సీ షార్ట్ చేసి వస్తుంది, కానీ ఎర్రర్స్ ఉంటాయి అన్నమాట. ఆ ఎర్రర్స్ మనం నెగ్లెక్ట్ చేస్తాం, కానీ ఆ ఎర్రర్స్ ఉండకుండా ఉండడానికి ఎల్పిఎఫ్ అనే సెపరేట్ వాట్ మీటర్ ని డిజైన్ చేస్తాము. ఇది నేను మిస్‌లేనియస్ టాపిక్ తర్వాత చెప్తాను, బట్ ఇప్పుడు చెప్తున్నాను. ఎల్పిఎఫ్ లో వాట్ మీటర్ లో ఒక కాంపెన్సేటింగ్ వైండింగ్ అనేది ఉంటుంది అన్నమాట. ఇదంతా ప్లేస్ చేసి సెపరేట్ గా ఎల్పిఎఫ్ కి సూటబుల్ అయ్యేటట్టుగా డిజైన్ చేసి ఎర్రర్స్ తక్కువ వచ్చేట్టుగా డిజైన్ చేస్తాం. అది పాయింట్.
ఓకే ఓకే సార్.
మీరు యూజ్ చేసుకోవచ్చు, ప్రాబ్లం లేదు, కానీ బెటర్ ఎల్పిఎఫ్ వాట్ మీటర్ అన్నమాట. అది పాయింట్.
సార్ మళ్ళీ నేను 2 వాట్ మీటర్ సమ్ అవుట్ చెప్పా కదా సార్. అంటే ఒక ఫేస్ లో మనకి వాట్ మీటర్ రీడింగ్ అనేది 0 తక్కువ చూపిస్తుంది, మన కనెక్షన్స్ ఇంటర్నల్. ఆ ప్లేస్ లో మనం ఎల్పిఎఫ్ పెడితే అది డైరెక్ట్ గేట్ చూపిస్తుందా ఆ సమ్ లో?
లేదు, ఎందుకంటే అది 3 ఫేజ్ నోటేషన్ కదండి, అది నో లోడ్ కండిషన్ కాబట్టి ఎంసీని రివర్స్ పెడతాం జనరల్ గా.
ఓకే ఓకే.
ఇక్కడ నేను ఎల్సీ షార్ట్ కంపల్సరీ అని చెప్పలేదు. ఏం చెప్పాను నేను, ఐదర్ కరెంట్ కాయిల్ లేదా పొటెన్షియల్ కాయిల్, ఎంఎల్సివి కదండి. ఈ రెండని రివర్స్ చేయండి, ఈ రెండైనా మనకు కావాల్సింది అక్కడ రివర్స్ కనెక్షనే. ఎల్సీ కంపల్సరీ కాదు, కానీ ఎల్సీ కూడా వచ్చే ఛాన్స్ ఉందని చెప్పాను.
ఓకే ఓకే సార్. మామూలు జనరల్ డౌట్ సార్, ఇప్పుడు మనం సప్లై ఇస్తాము, తర్వాత ప్యారల్ గా వోల్ట్ మీటర్ కనెక్ట్ చేస్తాం, తర్వాత దానికి లోడ్ కనెక్ట్ చేస్తాం. ఇప్పుడు ఆ వోల్ట్ మీటర్ లోడ్ యొక్క వోల్టేజ్ డ్రాప్ మెజర్ చేస్తుందో, మన సప్లై వోల్టేజ్ డ్రాప్ మెజర్ చేస్తుంది?
మీరు ఎలా కనెక్ట్ చేస్తే దాన్ని బట్టి. ఇది లోడ్ అండి, ఇది సప్లై అండి. ఇక్కడ కనెక్ట్ చేసి రెండు సేమే కదండి, విఎస్ రెండు సేమే, రెండు ఇక్కడ కనెక్ట్ చేస్తాం. అది లేదు అంటే
రెసిస్టెన్స్ ఏమైనా మధ్యలో ఉందా?
అది చెప్తాను. ఇది ఇలా పెట్టామనుకోండి, అప్పుడు ఏం మెజర్ చేస్తుంది,
విఎల్ సార్.
విఎల్, వెరీ గుడ్. ఓకే, ఇక్కడ పెట్టామనుకోండి,
ఓకే ఓకే, విఎస్.
ఎస్, అది.
ఓకే, థ్యాంక్ యూ సార్.
ఓకే రైట్. Okay then, tomorrow we'll meet.
Hello.
Who is there?
सर मैं अब्दुल बात कर रहा हूँ सर.
Yeah, tell me.
सर ये बोले था शंट मैग्नेट हैव हाईली इंडक्टिव नेचर.
Yeah.
इसके वजह से क्या होता कि बोले फिर से एक बार बोलो सर.
Yeah. इसकी वजह से क्या होगा बोले तो, इंडक्टेंस ज्यादा रहे तो, कौन सी कॉइल में, पोटेंशियल कॉइल में ज्यादा रहे तो इसकी वजह से क्या हो रहा, एलपी बढ़ जा रहा. ओके, एलपी बढ़ गए तो एक्सएलपी भी बढ़ गया.
ओके,
राइट. अब क्या होगा, ये आरपी मान लो, ये एलपी था, राइट, ये क्या है डेल्टा. ओके, ये एक्सएलपी मान लो, एक्सएलपी बढ़ गया, क्या हो गया, डेल्टा इंक्रीज हो गया. डेल्टा इंक्रीज हो तो क्या हो गया, एरर कम हो गया. साइन डेल्टा माइनस फाइव इज देयर नो. डेल्टा इंक्रीज हो तो एरर कम होगा, इसलिए हाईली इंडक्टिव कॉइल कनेक्ट करना होगा.
अच्छा 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 सर. और एक बार फेजर डायग्राम ओपन करो ना सर, एनर्जी मीटर का आखिरी स्लाइड आने.
या
इसमें एक बता दो सर, हमें क्यों VL इक्वल टू V फेज ली, ये बात नहीं समझ में। मैं सोचा कि ये डेल्टा कनेक्टेड होना
नहीं
इसलिए।
नहीं 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 नो, मैं EMMs में बताया, देखिए ये सप्लाई वोल्टेज है V फेज, ये लोड वोल्टेज है VL। देखिए VL डायरेक्टली यहाँ पे अप्लाई किया अक्रॉस द लोड, ओके, लोड के अक्रॉस ऐसा आया, करंट कॉइल में ड्रॉप कितना है, वेरी लेस है ना यार, नेग्लेक्ट किया हम, इसलिए V फेज को हम VL लगा दिया। समझा? करंट कॉइल में कभी भी इंपेडेंस नेग्लेक्ट कर सकते हैं हम। सो VL बोले तो लोड वोल्टेज, V फेज बोले तो सप्लाई वोल्टेज, यहाँ पे वो फेज नहीं है, ये सप्लाई वोल्टेज है। कम ऑन, वेरी गुड।
अच्छा सर, और एक बार ओपन करो सर फेजर डायग्राम।
या
हाँ, ये इसके वजह से एक सर इसमें दो में एक बता दो सर, थोड़ा एक व्यू बोल दो सर थोड़ा।
VL इक्वल V फेज तो समझ में आया ना?
हाँ ओके सर।
लोड करंट, लोड जनरल लैगिंग लिया मैं,
अच्छा,
लोड करंट 5 से लैग हो गया
जी।
IL को क्या लेते हम, IC भी लेते, दोनों इक्वल है।
ओके सर।
IP कहाँ पे है, पोटेंशियल कॉइल का अभी बताया मैं, हाईली इंडक्टिव है, सो IP V फेज से ज्यादा लैगिंग हो जाएगा।
अच्छा, अप्रोक्सीमेट 90
या अप्रोक्सीमेट 90, ओके। इसके बाद 5C IC के इन फेज में आएगा, 5P IP के इन फेज में आएगा। क्यों?
हाँ सर, ओके ठीक है सर, ठीक है।
बाद में EEC लैग में आ गया 5C से।
अच्छा, ये 5C से हुआ लैगिंग,
5C से क्यों? ये
ओके ओके।
राइट, इसमें क्या होगा, EEP 5P में लैगिंग होगा, बस। EEP lags by its own flux 5P, EEC lags by its own flux 5C। see, EEC C current, 5C C current, that's it। इसके बाद अल्यूमिनियम डिस्क कभी भी इंडक्टिव है ना यार, IEC lags EEC, IEP lags EEP, alpha is depending on अल्यूमिनियम डिस्क।
सर और एक है सर कि आप एक प्रॉब्लम लिखे था, ये वाटर बॉयलर सम फ्रीक्वेंसी फाइंड आउट करने का। सर वो पता चला सर, PT इक्वल टू VMIM/2 माइनस VMIM/2, हाँ है ये सर। कैसा बोल रहे हैं सर आप, डबल फ्रीक्वेंसी को? ये
देखो यार, देखो ये अंडरलाइन किया ना, 2 ओमेगा है यहाँ पे, यहाँ पे कितना है, ओमेगा है। फ्रीक्वेंसी बोल तो क्या है, साइन ऑफ 2πft, कॉस ऑफ 2πft, नो प्रॉब्लम, ओमेगा 2 ओमेगा डबल।
अच्छा, ये आउटपुट ले रहे हैं सर ये आप?
क्या आउटपुट? पावर में ये सी क्या पूछा उन, पावर का फ्रीक्वेंसी पूछा, ये वोल्टेज ले, करंट लेके पावर का, ये आउटपुट इनपुट की बात नहीं, पावर का फार्मूला में कहाँ है फ्रीक्वेंसी, यहाँ पे 2 ओमेगा।
अच्छा 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 सर, और एक है सर, ये क्या है कहते हो आप, एक प्रॉब्लम बोले सर, ये स्टार्टिंग में डिफ्लेक्टिंग टॉर्क के टाइम पे एक प्रॉब्लम बताया था।
आज ही बताया?
नहीं सर, ये पहले का सर, ये शायद सेकंड या थर्ड क्लास का। 0 to
send that question, it's better. Can you send that question to WhatsApp, my WhatsApp?
नहीं सर, आप 1 मिनट में बोल देते हैं सर।
नहीं, ओके ठीक है, बोलिए
सर। 0 to 4 amperes डिफ्लेक्टिंग टॉर्क सब, हाँ ये मीटर को 0 to 4 amperes सर। हाँ, डिफ्लेक्टिंग टॉर्क रीड किया 4 amperes व्हेन स्विच इज ऑन।
हाँ वो क्वेश्चन, ठीक है, राइट।
हाँ, ये फ्रीक्वेंसी नहीं है सर, ये DC का सर पूरा।
0 to 4 एम्पीयर किसको दिया?
एक मीटर को दिया था सर। कौन सा आप? अमीटर को दिया सर, DC अमीटर।
ओके,
हाँ, तब वो डिफ्लेक्टिंग टॉर्क आके 4 amperes रीड किया सर। हाँ, अगर मैं उसके बाद स्विच ऑफ कर दिया मैं, तब डिफ्लेक्टिंग टॉर्क 0 amperes दिखाता ना सर?
0 एम्पीयर दिखाता।
हाँ, तब TC कितना जनरेट होता है? तो TC भी 0 ही दिखाता, बोले आप
क्या?
TC कंट्रोलिंग टॉर्क, देयर इज नो अपोजिशन टू द डिफ्लेक्टिंग टॉर्क, दैट्स व्हाई द TC विल बी रीड्स 0 का बोले था ना सर?
नहीं समझ रहे यार एक्चुअली।
नहीं सर, डिफ्लेक्टिंग टॉर्क विल रीड 0, राइट?
Deflecting torque will read 0.
Pointer, I'm sorry, due to pointer.
The pointer reads 0 when
switch is at off condition.
स्विचेस इट ऑफ कंडीशन, ओके स्टार्टिंग पे या 0, ठीक है।
हाँ सर, 1 मिनट से मैं फिर से बोलता हूँ। मैं स्विच ऑन करते से टाइम पे पॉइंटर 4 एम्पियर्स दिखाया सर।
या ठीक है।
हाँ, उसके बाद मैं स्विच ऑफ कर दिया, पॉइंटर 0 दिखाया।
0 पे आएगा, हाँ ठीक है।
हाँ 0 आएगा पॉइंटर।
या
तब टीसी दैट मींस कंट्रोल इन टार्क उधर एग्जिस्ट नहीं हुआ, इसलिए 0 हुआ कंट्रोल इन टार्क।
नहीं, वैसे नहीं बात बोला मैं, वैसे नहीं बोला।
हाँ।
क्या बोला मैं, देखिए 4 एम्पियर सप्लाई दिया, टीडी प्रोड्यूस हो गया, थीटा भी है, पॉइंटर 4 एम्पियर बताया, ठीक है।
हाँ अच्छा।
अगर सप्लाई 0 किया,
हाँ
टीडी 0 बन जाएगा,
हाँ
है ना। पॉइंटर कहाँ पे था, 4 पे था,
हाँ
राइट। सप्लाई क्या दिया मैं, सप्लाई स्विच ऑफ कर दिया, स्विच ऑफ कर दिया तो क्या हो गया, टीडी 0 हो गया।
ओके।
टीडी 0 होने के बाद टीसी तो रहेगा वहां पे, वो टीसी ये पॉइंटर को 0 पे लाएगा। ये पॉइंटर 0 पे आने के बाद टीसी भी 0, टीडी भी 0, एवरीथिंग इज 0। क्यों, वो भी बात भी बोल रहा हूँ। अगर मैं स्प्रिंग ओनली एक ही स्प्रिंग ले रहा हूँ, ये ऑपरेशन में टीडी है ना, यहाँ पे स्प्रिंग क्या हुआ, कॉन्ट्रैक्ट हुआ समझो, कंप्रेस हुआ समझो।
हाँ
ठीक है। पॉइंटर ऐसा सप्लाई ऑन की कंडीशन में, सप्लाई ऑन कंडीशन में पॉइंटर ऐसा मूव हो रहा, स्प्रिंग कॉन्ट्रैक्ट हो रहा, टीसी भी ऐसे आ रहा, क्या हो गया, टीसी टीडी दोनों इक्वल हो गया, पॉइंटर स्टॉप हो गया, ठीक है।
हाँ
राइट। अब सप्लाई ऑफ करे तो इधर का फोर्स 0 हो गया, इधर का फोर्स 0 हो गया तो स्प्रिंग के ऊपर जो कॉन्ट्रैक्शन का फोर्स था वो 0 हो गया। जब क्या होगा, स्प्रिंग
रिलैक्स
ट्राइज टू गो बैक टू एक्सपैंड, एक्सपैंड हुए तो पॉइंट यहाँ पे आ जाएगा।
तो टीसी एग्जिस्ट होगा।
हाँ डेफिनेटली। जब तक, कब तक एग्जिस्ट होगा, जब तक द पॉइंटर रीच होगा, अब तब तक द टीसी एग्जिट होगा। बट टीसी एग्जिट होने के बाद इमीडिएटली 0। बट आप ये क्वेश्चन भी पूछ सकते हैं, सर टीसी कभी भी टीडी के ऊपर डिपेंड होता ना, वही है। टीडी 0 हुआ, टीसी इंस्टेंटली 0 नहीं होगा, ये स्प्रिंग को क्या होगा यार, रिवर्स में आ जाता है, विद इन फ्रैक्शन ऑफ सेकंड्स में टीसी भी 0 होगा, बस एवरीथिंग विल बी 0।
अच्छा, सेम यही प्रिंसिपल को एक प्रॉब्लम किए ना सर, आप खुद करे था, स्टिफनेस वर्सेस स्ट्रेंथ ऑफ मैग्नेट को। उसमें भी इसके वजह से एक इंक्रीज हुआ, एक डिक्रीज हुआ।
वेरी गुड, सेम हुआ, राइट।
अच्छा, इसका रिलेटेड है ना सर वो भी?
हाँ इसका रिलेटेड सिंपल है, मैं वो भी रिवर्स कर रहा हूँ। टीडी कम हो गया उसमें, टीडी कम हुई तो क्या होगा, पॉइंटर कम बताएगा।
हाँ।
टीसी कम है समझो, अपोजिशन कम है, पॉइंटर ज्यादा बताएगा। अपोजिशन कम है,
जी
कम हो, इसलिए ये ज्यादा ये कम दोनों को मिला के 0.2% रीडिंग आ गया।
अच्छा,
ठीक है।
ओके थैंक यू सर, थैंक यू।
ओके गाइस, टुमारो 5 o'clock, थैंक यू।